Ladies and gentlemen, welcome back. The 37th TWNIC IP Open Policy Meeting is held as a parallel meeting with ICANN APAC. We will now proceed to the IP Open Policy Meeting for the Cybersecurity Special Interest Group. In this session, we're going to focus on product security, incident response, and management. The moderator for this session is Mr. Jamie Gillespie, Internet Security Specialist at APNIC. Mr. Gillespie provides security training, outreach, and development of computer security incident response teams, network operators, and law enforcement agencies across 56 economies in the Asia-Pacific region. I will now hand the floor to the moderator, Mr. Jamie Gillespie. Mr. Gillespie, the floor is yours.
That introduction, and welcome back everyone after the break for today. As introduced, this is the Cybersecurity Special Interest Group, or SIG. The topic for the presentations that we're looking at today for this session is around product security, incident response, and management. So this workshop will be sharing processes, practices, case studies of cybersecurity events and vulnerability handling. With me for presentations today, we have 4 experts in their fields. First off, we're going to be having a presentation from Yoichi Ekeo from the software ISAC and Saibuzu. We also have Robert Chin from ASUS. We also have Neko Lee presenting from Unisix, and Takayuki Uchiyama presenting from Panasonic. So first off, I'll be handing the presentation floor over to Yoichi-san to present. Thank you.
Hello, everyone. I am Yoichi Akeo. Today, I will introduce a piece of service framework published by FIRST. Please enjoy my presentation video. Let's get started.
Hello, everyone. 你们好. Nice to meet you. I'll talk about PSAP today. At first, I'll introduce by myself. I'm Yoichi Akeo. 我叫名为杨毅. I belong in Cybersecurity Office Manager and PSAT Research Group Leader in Software ISAC. I joined in Cybers on 2001 and belong Development Division. We start the bug bounty program on 2014. I tried to work as CSAT on 2017. And I gave PSAT advisor service for other organizations on 2020. About Cybers, we listed at Tokyo Stock Exchange prime market segment. We have several branches. Example, in Shanghai, Shenzhen, and San Francisco. We provide cloud service called cybers.com. On cybers.com, you can use our several products. Amount of introducing companies are following. We have a branch in Taipei. The branch's domain is cybozu.tw. We provide 2 services, Kintom and Garoon. You can use our products in Taiwan. Today's agenda is as following. What is PSAT? PSAT Services Framework. Difference from CSAT. What is PSAT? PSAT is Product Security Incident Response Team. CSAT is Computer Security Incident Response Team. PSAT is responding to their product incident. I think that IoT device maker and service provider need to establish a PSAT. There is a document about PSAT named PSAT Services Framework. It's written by FIRST. It describes about PSAT need to do. The URL is there. It defines the PSAT services. The service area defines 6 areas. The service area 1 defines stakeholder management for supporting the existence of PSAT. PSAT service area from 2 to 5. These are PSAT tasks. Service area 6 is for strengthening PSAT capabilities. Service area 1 says that PSAT need to manage their stakeholders, especially the executive is the most important stakeholder. If PSAT has no budget, PSAT can nothing to do. Security researchers might send useful reports for your product vulnerabilities. The developer will fix the finding vulnerabilities. How to manage stakeholders? We have a meeting with executive every week. You need to be interested in company management. 2. Share threat information. Phishing mail, malware, security incident information happened as an organization. Service area 2 define PSAT activity for find vulnerability. At first, PSAT need to set up a report form for vulnerability. Do the security testing for find vulnerability. Early finding is helpful to reduce product risk. There are several ways to find them. Set up a vulnerability report form, do security testing in-house, ask the security vendor to do security testing, run a bug bounty program. Cyborg has a bug bounty program. If you have any skills to discover web services vulnerability, please try it. Service area 3 defines PSAT activity to triage the vulnerability. When PSAT get a report, PSAT confirm it is reproducible. If PSAT cannot decide the severity, maker cannot release the patch appropriate timing. PSAT need to ready reproducible environment for when PSAT gets a vulnerability report. Patch release timing is decided the following situation. Emergency patch to exploit is too easily. Disclosed exploited code or heavily damaged if it would be exploited. Regular update to exploit is not easy. No exploit code or light damage if it would be exploited. Service area 4 defines release the remediation process. Remediation might be patch release or announce the mitigation. Service area 5 defines the vulnerability disclosure process. The vulnerability need to disclose in their release note when it's fixed. Otherwise, the release patch might be forgotten to apply. Disclosing vulnerability is so difficult. Disclosing is useful for users. When the user gets a report, user can decide to apply the patch. However, the report might make your product reputation down. Competitors may also use that information to damage your reputation. But I think we need to disclose them to save our customers. Before, we faced this problem. When we disclosed our vulnerability, then one of competitors spreaded it and said their product have vulnerability. It might be dangerous to use. Our product manager says that stop disclosing it. We discussed this problem for a long time. Finally, we decided to continue disclosing. The final deciding factor was a word from our executive. Disclose for our customers. Stakeholder management is so important. Service area 6 defines the TWNIC to get continuous support from stakeholders and to improve PSAT's capability. We run incident response training every year for confirming incident response process and each person's role. They who participate in this program notice importance of security team after this training. CSAT member needs to respond from organization IT system and information assets incident. PSAT member need to respond for their product vulnerabilities. PSAT and CSAT have many differences from their targets, process, interest, skills, and stakeholders. But they need to cooperate about sharing technical skill, threat intelligence. And their cooperation is useful for improving their organization's security awareness. PSAT maturity document written by FAST describes how to establish a PSAT step by step. After all, what I want to talk to you are 2 points. Check PSAT. When you buy a software, IoT device, or cloud service, please check the maker or provider has PSAT. Read PSAT service framework. If you consider to establish a PSAT, please read the PSAT maturity document and the PSAT service framework. Thank you for watching. 谢谢。
Thank you very much, Akeo-san, for that excellent presentation on PCERTs, going through service areas and the need, of course, for executive support and stakeholder management. So a very good overview of that process. Coming up next, our next presenter is Robert Chin, who's presenting from ASUS. Robert, the floor is yours.
Hi, thank you. Good afternoon, everyone. This is Robert Chin. Welcome to Taiwan, physically or virtually. My name is Robert Chin. I'm the CISO of ASUS Tech. I'm also the chairman of ASUS, what we call the Information Security Committee. From the industry cooperation point of view, in Taiwan, we established two major information security alliance. The very first one is Taiwan High-Tech Information Security Alliance. This includes 10 high-tech companies from the semiconductor to the ODM, OEM company. I'm the chairman of the alliance. And also just this month, we established what we call the Taiwan CISO Alliance. So this is under the government's sponsorship. So I myself today, I would like to share with you the product security incident response and the management of ASUS Tech. In the very beginning, from ASUS point of view, we have a special delegate team, what we call the Digital Security Division, to handle our product security, our information security. So our slogan is building a digital resilience and enhancing brand reliance. Maybe you know ASUS, we are one of the top 5 PC company in the world. And also in terms of brand image, ASUS, we are the #1 in Taiwan. And also our slogan, ASUS slogan is pursuit of excellence. So we want to upholding of security. So today, my 2 experience sharing regarding the very first one happened in February this year is one of ASUS subsidiary, what we call the ASUS Store. ASUS Store is a NAS product, network attached storage product company. It was attacked by deadbot ransomware in February this year. And another one I would like to share with you is regarding our Wi-Fi router business unit product targeted by Cyclops Blink malware. That was happened in March this year. So the very first one is regarding our subsidiary ASUS Store. And it was happened in February 22nd this year. And from the end customers, they received this kind of ransomware from deadbot ransomware. So this not target to the company infrastructure or website of ASUS Store, but it target end user who bought the product. So from here, you can see the ransomware, it blocked the data and asked for ransomware payment of 0.03 Bitcoin. That's about $1,088. And also the hacker left a message that this is ASUS Store's product. And also you can ask for the support from the company. This page share with you that is the ransomware later itself. So here you can see the hacker mentioned this is a 0-day vulnerability. And in terms of the payment, it asks for, just now I mentioned for end user 0.5, but it asks for company to pay 7.5 Bitcoin. That's about $272,000. And if ASUS as a company want to have complete solution, including the decryption key and the vulnerability detail, ASUS has to pay 50 Bitcoin, that's about 1.8 million US dollar. So in the right-hand side, right button, you can see that, in fact, the same case, similar case happened in January 26 this year. The same hackers attacked another NAS company. It's also a Taiwanese NAS product company. It is called QNAP. So from the ransomware later, and also its status, it is the same as what happened to ASUS, our subsidiary, in February. So like everybody knows, in terms of how to manage the incident, no matter from CSIRT or PSIRT point of view, basically there are three different stages: before or during the incident or after. So definitely from ASUS group point of view, we don't want to see this kind of things happen, no matter cybersecurity or product security. But we do have a good mechanism in terms of our security policy. We have a 3-year, 5-year security plan, and internally, our Information Security Committee, we have 3 major missions. One is to manage, to handle our C13. The second one is P13. The third one is ASUS Group, and also our worldwide 70 countries, all the branches, and also we train, educate our employee worldwide. And in terms of triage, no matter for the incident detection, analysis, or with the help from some of the information security service company, and how to document, how to prioritize or notify law enforcement. That is the SOP. And then to the response, how to solve the issue, how to let our customer know, how to put on our website, or how to manage the medias. And then the post-incident lesson learned or follow-up report. So that is everybody's standard procedure. So for this particular case, this is the very first time it happened to the subsidiary, ASUS Store. So as you can see, there are many news clips around the world, no matter from the media, NAS compares, or even in Taiwan, many media, because ASUS is #1 branded company in Taiwan. So internally, we have a task force team to work with our PR, to our speakers, or to our legal team, or to different product BU team to handle incident like this one. So here, I would like to thank you for TWNIC, TWCERT/CC's help. From here, you can see the case happened within 59 hours. 59 hours. We share on our product side to let the customers worldwide to understand the incident and how to establish, and then we keep informing the customers what is our solution. So from the left-hand side of this page, that is the corporate website of ASUS Store. So to teach our customer how to protect and what is the new firmware, new OS we have prepared for customer. Then in the middle of this page, you can see on the TWCERT website, although it's announced how is this case and how ASUS suggests its customers to protect. And the right-hand side, also that's on the TWCERT corporate website. ASUS Store has released the new firmware, the new patch for customer to change. So as a good corporate citizen, we have the responsibility to remind our customer globally on website or our sister team to deliver to customer worldwide. So again, thanks for TWCert and the CC. The lesson learned. So definitely from ASUS point of view, from later I will also share with you group point of view. The group, we can support each other to support the subsidiary. In the total, we have identified 10 subsidiary under the whole group information security network. And the second thing, the second lesson we learned, security engineering. The vulnerability this time is RCE. So definitely we have to make sure our different product BU or different subsidiary to follow SSDLC to make sure the application or OS, they are secure. And another thing is this ransomware deadbot. Yeah, we don't know because definitely the main purpose of the hacker is for ransom. So definitely from ASUS group point of view, we want to protect ourselves, and also we don't like to let our customers to lose money. And the last one is regarding the IoT related device like a NAS. So we work together with Taiwan's Ministry of Economic Affairs. Under its MOEA, there's an Industrial Development Bureau regarding the industry standard and how can we avoid this in the future. So that's the very first case I would like to share with you. The second one is within ASUS, we have a Wi-Fi router business unit. So in March this year, this Russian hacker, they use Cyclops Blink to focus on ASUS routers. So the left-hand side of this page is the blog on Trend Micron. It talks about the background. And the right-hand side is the media in Taiwan. So from Trend Micron's research summary that you can refer this on its corporate website. So this is Russian hackers. And for this particular case, it happened as early as February that in UK, the NCSC, this target WatchGuard Firefox router. And also Trend Micron got this and also share with ASUS. And then we identify this also together with Trend Micron and with the support from NCSC and even USA FBI. So there are about 100 to 200 WatchGuard and the ASUS router device were impacted. So the observation and also the advice that from the, at this moment, we don't know what's the intention, but definitely for this kind of behavior that is not good for any device company in the whole world. So this hacker's behavior, this is modularized solution. So it may impact to other brand, not only ASUS, but also around the world for different router device. So we would like to share this with everyone and hope nobody will get hurt. So for the new scripts, here you can see from ASUS corporate website. So we have announced this within 62 hours when it happened. And also on TWCert corporate website, it also mentioned about this and how ASUS solved this. So as I mentioned, our internal team within 64 hours will respond and share with our customers. So the lesson learned still, router BU is one of ASUS internal BU. So also we have monthly meeting to work with our P13 or C13. Also, and what we learned is if in the industry, other company got hacked, we should learn this more earlier and how to prevent this happening to ASUS. And also similar case is regarding security engineering to follow SSDLC. And then the response. So internally, we do have this SOP 6W1H, and we practice this from time to time. So as you know, ASUS is a product company. So we have many different products like a notebook, like a motherboard, or I myself, I'm also the head of server BU. So we do believe this triangle, it links together each other's. So information security depends on product security. We have a secure product, then we can have a better information security. So ASUS, our slogan, one of the philosophy is beginning with the end. So we want to make sure with security by design and the security by default. So this page share with you from the software design point of view. I think everybody, every company follow this standard, no matter depth, security, operation. So from SAST point of view, SCA point of view, DST point of view, or IST point of view, or even penetration test. So ASUS will follow this by using different commercial tools to scan, to do the testing. And also we hire outside red team company to do penetration tests every year. So this page share with you the joint defense alliance or coalition within ASUS, the company itself. We have information security committee. We have a delegate security team, what we call the digital security division, and the focus on PCERT and the CSERT. And from group point of view, ASUS group, we identify 10 subsidiaries under the whole group. Then from the whole industry point of view, as I share with you in the first page, I myself, I'm the chairman of a high-tech information security alliance in Taiwan. The 10 company in this alliance, the revenue last year is about 4.2 trillion new Taiwan dollars. Then just this month, we formed another new alliance, what we call the Taiwan CISO Alliance. The 14 founding companies, annual revenue is more than 3.1 trillion new Taiwan dollar. So we want to make sure the whole industry is linked tightly. And also we want to make sure the whole supply chain is safe. Then last but not least, we work together with international CERT, with Taiwan CERT, and also with local government, our national security, our police station, our similar organization like a FBI, Law Enforcement Alliance organization. So that is our joint defense collaboration here in Taiwan. So my last page, security engineering, security anytime, anywhere. We hope every company can be secured and can sleep well. Thank you.
Thank you very much, Mr. Chin, for your presentation. It was very good seeing the vulnerability case studies that you presented and highlighting the importance of embedding security in the software development lifecycle and the usefulness and importance of engaging with national CERT as well as law enforcement. Thank you again.
Thank you, it's my pleasure.
Up next, we have a presentation from Netco C.Y. Lee presenting from Unisix. I'll hand the presentation to you, Mr. Lee.
Thanks, Jamie. Hello, everyone. Can you hear me?
Yes, we can.
Yes.
Okay. Good day, everyone. I'm Neko from Unisix Holding Corporation. I'm in charge of the product security department. Today, I am glad to be here to share a short story about LightSail PCERT. I believe that most of you know the name Zycel, but not UNIZEX. Before my presentation, I will spend a few minutes to talk about the relationship between UNIZEX and Zycel. The UNIZEX Holding Corporation began operations in 2010 in Hsinchu, Taiwan, as it was set up to reorganize from Zycel Communications, which was founded in 1989 by Dr. Zhu Shunyi. UNIZEX Group offers complete networking solutions for a wide range of deployment scenarios. From this picture, there are 5 major subsidiary corporations in the UNIZEX Group, and the term Zycel is a brand name shared by Zycel Communications and Zycel Networks. Zycel Communication is a technical service provider and focus on ISP networking business. And Zycel Networks focus on channel business, such as providing cloud, security, and mobility solutions. The others, MitraStar provides networking design and manufacture services, such as ODM and OEM service. Black Cat provides cybersecurity defense service. And the last one, X Square focuses on 5G system on module R&D. UNIZEX has over 30 years of networking expertise and also has several subsidiaries in America, Southeast Asia, Europe, and the Middle East. There are more than 20 million devices shipped per year, creating global connections. UNIZEX Group provides one-stop shop for total solutions, from technical COE to the CPE, from business to home solutions, even the defense industrial and IoT service, and so on. We offer a comprehensive range of products and solutions that work end-to-end, giving users a truly one network experience. We achieve this by using innovative integration and combine this with a series of technology to achieve a secure and ease of use experience for both end users and the IT maintaining teams. Currently, our networking services are offered in over 150 countries and territories around the world. In a word, Zycel is your networking ally. Now, let us move on the way to Zycel P-Cert. With vulnerabilities increasing years on years, no company can be completely vulnerability-free. So we need a P-Cert to focus on product security issues for Zycel products, where PSIRT stands for Product Security Incident Response Team. What is a P-Cert? we will talk about the PSIR role and its responsibility. PSIR is focused on the identification, assessment, and the remediation of the risk associated with the product vulnerability. It also coordinates and offers solutions for stakeholders. Accepting vulnerability reports, communicating with vulnerability reporters, vulnerability triage and analysis, coordinating vulnerability remediation activities, publishing advisory for disclosed vulnerabilities, and crisis management are the main 6 responsibilities of a PSIR. How to build a PSIR? PSIR usually acts as an internal security service provider, and the operational foundation is the most important cornerstone. Therefore, I will describe the following 5 foundations of core components to plan, establish, and effectively operate a PSIR. First, we need to obtain sponsorship from the organization's key decision makers, such as CEO or CISO. Then, identify the cost of the resources required to operate the PSIR and obtain a suitable funding to finance these resources. Third, identify the staffing resources needed to provide your PSIR service. To provide your service to the stakeholder, like the pictures displayed. And we need to obtain skilled members to work on this. Fourth, identify and acquire other necessary resources and tools. Finally, we need to document some policies, processes, and procedures related to conducting PSIR operations. The security incident process and SOP for LightSail can be divided into 5 phases. LightSail PSIR is a cross-departmental team. The members come from different departments. For example, when we receive a security issue, the security experts will work with the product line R&D team to perform vulnerability triage and analysis. If it was confirmed as a vulnerability, R&D team must propose a possible solution for bug fix or functions enhancement. Then, the product line managers will prepare the patch schedule if their products are affected. Meanwhile, PQA team will help to verify the beta solution and help to release the final version of patch firmware for vulnerable products. The CSO team or sales become the first line contact person to provide patches or service for customer when the security advisory was published. Finally, the PR team will work for media monitoring and worldwide media engagement after the vulnerability was disclosed. In a word, different teams are engaged in complementary activities for security incident processing. Currently, we have a dedicated PCERT to handle all licensed product-related security issues. We also have a robust reporting channel and disclosure policy. And we work with third parties, such as international CERT, security researchers, or other PCERT teams, and so on. And we also work with the CV program to slab and disclose vulnerabilities to ensure optimal protection for our customers. Where the CV program identifies and catalogs security vulnerabilities in software and hardware components worldwide. ISL took an active part in the CV program and actively become a CV numbering authority named CNA. In fact, ISL is the fourth CNA and the first public trade company recognized by the CV program in Taiwan. Till April 2022, only 216 organizations from 34 countries have been named CNA. ISL is one of them, joins a small group of security-minded networking brands, and is one of the first in the small and medium-sized business market to receive the authorization. What matters is how we face and handle vulnerabilities, and being made a CNA is hard-earned recognition of how seriously we take these issues and the work we put into address them. Finally, this is my conclusion. I talk about the benefit to build a PCERT and the benefit to become a CNA. However, we still face some challenges. All in all, securing your products and service is a journey, not a destination. Even though we might face challenges in this journey, just keep working on the way to a sound PCERT and enjoy it. Thank you for your listening. This is my presentation. Thank you.
Thank you very much, Mr. Lee, for that very interesting presentation. Again, highlighting benefits of building a PCERT, the incident processing lifecycle, and of course, highlighting the different teams that are involved along different phases of the incident processing lifecycle as well. So thank you very much.
Thank you.
Our next presentation is from Takayuki Uchiyama, presenting from Panasonic. I will hand the floor over to you, Taki-san.
Hello, can everybody hear me? Sorry, I was having problems with unmuting my mic.
Yep, we can hear you.
Okay, thank you. Thank you for the introduction. My name is Taki Uchiyama. I'm from Panasonic. I'm from the Panasonic Product Security Center. And today I'd like to talk about our IoT product security at Panasonic and sort of the product security activities that we go through, that we ask of our product developers to make sure that products that are shipped from Panasonic are safe and secure. Through the wonderful presentations of the three folks that preceded me, some of the ideas or things that I may discuss here today may be repeated, but these are some of the things that I'd like to talk about what we do here at Panasonic. So before I actually move on, I'd like to quickly introduce myself. My full name is Takayuki Uchiyama. I go by Taki. I work for the Product Security Center here at Panasonic. I'm the manager of our global promotion section. And this is, I won't read through the bio, but this bio just includes some of the things that I've done in my security career. In a past life, I was part of the JP CERT Coordination Center, the national CERT here in Japan. I was a coordinator of vulnerabilities, and I also worked as a global liaison. And since 2018, I've been part of Panasonic as part of the global, in charge of our global product security activities. I'm also a member of our Panasonic PCERT, and I've also been a CV board member for the past 5 years. And CV was just mentioned in the previous presentation. So I'm part of the board that makes decisions, strategic decisions on how CV does things and how to move forward as far as how to make CV useful to the community. So without further ado, I'd like to go through what we do as far as product security here at Panasonic. I won't waste too much time here on this slide. It's just a quick primer as to why we need to secure our products. IoT is continuing to evolve at a very, very fast pace. Attackers have various points to conduct cyber attacks now. Devices that we never imagined that would be connected to the internet are now being connected at a quicker pace, whether it's wired or wireless. They have these connections, and devices with this type of connectivity is increasing exponentially. There are new services that are being provided on these devices, which are leading to information all this information is being sent through the internet, and all this information is very valuable to certain folks or a lot of folks. And there's motivation for attackers to obtain this information to either sell it or use it in some way to make more profits. And the other thing that we've noticed is the use of common technologies is increasing. Protocol operating system vulnerabilities are affecting many devices at the same time, as mentioned in one of the previous presentations, one of the case studies previously. And these enable attackers to target multiple devices at once. So it's very important for us to make sure that we ship out secure products. And I'd like to go over, in the next few slides, I'd like to go over some of the things that we go through or that we preach to our development teams as far as what they need to do to secure their products prior to shipment. So this slide is sort of our corporate social responsibility document. I just wanted to quickly go through this. We do promise to our customers that we want to make sure we ensure the security of our products through 3 main activities, which I'll go through over the next couple of slides. But this is a report, it's made public. There's a quick page on product security. So if you're interested, please go through. There's a link on the slide here. So the first activity I'd like to go through is human resource development. We go through as far as this is mostly for product developers. We do have certain courses for product managers. For example, for like incident response, we have a separate module for that. As far as some of our training courses that we provide through an e-learning platform where developers can just log in, watch a video, take a test. And we also have some courses available. We use Microsoft Teams to deliver courses through the Teams platform, just to kind of have discussions, provide certain trainings on certain topics. For example, the one on the slide here is the Introduction to Product Security. This is a very simple introductory course. It goes through why product security is important, Goes through some product security laws and regulations that are popping up around the world, stuff like that. And there's also other courses that would talk about secure design, threat analysis, how to secure the supply chain, etc. So we provide all these courses to our developers globally. And this is sort of the basis for our product security activities. As you can see, ensuring product security is a critical requirement for us at Panasonic. And we provide basic knowledge on product security as a base core. That's the training that I mentioned before. So, and there's two major pillars to product security here at Panasonic. The first side is to minimize risks, and the other part is is incident response. And that's where product security sort of sits on top of, and that sort of trickles up to the making sure that our networked and embedded devices and any services that we provide are secure and safe to use for our customers. And as was there was a slide similar to this in one of the previous discussions, but we have something similar to this as well. We promote activities throughout the entire product lifecycle. The first phase, during the planning phase of the product, we want to make sure that the minimize risks part is we want to make sure that we're preventing vulnerabilities from being introduced into the code. So the first part during the planning phase is to make sure we analyze any potential threats to the products through any services that are planning to be used or any, say, open source that may be used. So we want to make sure we're eliminating those risks or making sure that they'll be mitigated during the coding process. And then in the design process, we have various documentations on how to make sure vulnerabilities aren't incorporated. For example, how to prevent, for example, like cross-site scripting vulnerabilities, or how to prevent SQL injections. What is a SQL injection? We provide documentation around that to make sure that the products being designed are actually secure. And then the implementation part is to make sure that there's appropriate secure coding practices are being followed. And also as a best practice, we promote static analysis of the code itself. And then before it gets shipped, we want to make sure we verify or test the product or module or whatever may be shipped out for vulnerabilities prior to shipment. So we go through a vulnerability testing process before shipment. Vulnerabilities, as many vulnerabilities as possible, we'll make sure we eliminate. And then once the product gets shipped out, as was mentioned in some of the previous presentations, there's an incident response process that we also have. The PCERT is in charge of to make sure that if there's a vulnerability that's reported, we make sure that gets back to the development team so that the development team can remediate it, update it, and make sure it gets the update gets shipped to our users. But the basic message here, and I went through a lot, is that product security throughout the entire life cycle is the main key point here that I just wanted to mention. And I just want to quickly give a shout out to our testing team here within the Product Security Center. There's sort of some members are part of the PCERT team, but it's a dedicated team that hacks Panasonic products prior to shipment. So the development teams ship their products over to our testing team to make sure that the products are tested prior to shipment. And the testing team here has over 10 years of experience in doing various tests on IoT products, over 1,000 products, and they've discovered over 10,000 vulnerabilities, as was the last count that I had. But they're not necessarily new vulnerabilities or unique vulnerabilities, but they're vulnerabilities in the products that that come our way. So our team tests, they don't just test the IoT devices, they test various hardware, they do servers for IoT products, and any applications that are also necessary. So these are all included within the 1,000 count here. And as I mentioned before, we have an incident response process. We want to make sure that we respond to any reported vulnerabilities in a timely manner. And for this, Panasonic PCERT serves as the principal point of contact for internal and external communications. And also each business division that has development teams has its own incident response team that the Panasonic PCERT members interface with. So here's a quick sort of overview of what goes on. So the Panasonic PCERT is sort of in the center here. Once we receive a vulnerability report, we'll analyze it, And if we have the product, if the testing team tested the product previously, and we sort of need a little bit of additional information, or there's a little bit context that's missing from the report, we'll try and reproduce the vulnerability. Once we get that information, once we get enough information so that we can communicate to the development team on what the actual issue is, we'll send that over to the incident response team at the particular business division. The business division, once we're in contact with them, the Panasonic PCERT will help support any product security activities. Will help with any vulnerability coordination as far as communications to any external parties, may that be third-party coordinators or researchers directly. And we also share any information as far as any context around the vulnerability or any additional information we may get. So in doing that, we also we get reports externally. I have a screenshot of our vulnerability reporting form in the next slide, but we also interface with various other external organizations. As I mentioned before, JP-CERT is one of the national certs. They ingest vulnerability information from reporters as well. We've also had experience working with certs, national C-certs and other certs overseas. And we also ingest reports directly from vulnerability reports such as security researchers, security vendors, universities, and whatnot. And as I mentioned before, this is our vulnerability reporting form. It's available in both Japanese and English. We also have an advisory page that's available. And we also have a vulnerability disclosure, vulnerability coordination and disclosure policy document on this page as well. There's a PDF for those of you that are interested. And since our PCERT is not a dedicated team per se within the Product Security Center, as I mentioned before, I'm part of the Global Promotion Division. So as far as PCERT activities are concerned, PCERT activities get triggered once we get a vulnerability report, and that's sort of when the response process starts. But when we don't have any reports to coordinate at that particular time, or if there's a lull as far, we're waiting for, say, the development team to issue a patch, we have other daily work that we that we go through. So I call this a day in PCERT land slide. So the PCERT members have various different tasks that they have. We coordinate with developers. We review reports, external reports, vulnerability reports that may come in. We make sure we collect up-to-date information on things that are going on as far as IoT security is concerned. We have our daily work. For example, for myself, I coordinate with our global development teams overseas, looking from Japan, making sure that they're okay, or if there's any issues that they're looking for, or to deliver any trainings, internal trainings that I mentioned before. Those are some of the things that I go through. And one of the more engaging parts, or one of the more enjoyable parts as far as being part of the PCERT, is to collaborate with external organizations in forums such like this, albeit remotely. It's great to be able to talk to folks at forums like this, but hopefully in the future, hopefully in the not so distant future, we'll be able to actually meet each other and actually have discussions face to face. So that's sort of our product security sort of like activity part. And this is sort of one of our newer projects, and I'd like to take some time to kind of go through this. It's our introduction to our Asura project. It's a platform to strengthen IoT home electronic security. I'd like to take a few minutes and a few slides to go through sort of what we've done through this project. So one of the challenges in product security, as far as from a PCERT perspective is concerned, is that incident response or any response to a vulnerability requires a trigger, whether it be some internal notification or an external researcher reporting a vulnerability to us through the forum, through email, or whatever it may be. And one of the motivations behind this project was to make sure that Panasonic as a whole is not relying solely on external organizations to collect vulnerability information or threat information against our products. We wanted to be able to proactively analyze and utilize threat information so that we could provide to our developers, so that we're not waiting for a reporter to say, "Hey, you're vulnerable to this. You're vulnerable to this vulnerability. There's an exploit for your product somewhere on the internet." So we wanted to make sure we had a way to do that. So what we did was we created this physical honeypot. As you can see on the on the top right-hand side, you see an image of a bunch of home electronics that are connected to the internet. These are all directly connected to the internet, and we're collecting threat information against them. And some of the screenshots you see here are some of the dashboards that we have internally to sort of show the information flow from attackers to the devices and some of the statistics that we've been compiling. So what we've been doing in this project is to collect threat information using IoT home electronics in real time. So that's the first part. This is already ongoing. We've been doing this for a couple of years already. And what this is enabled to do is that it enabled us the ability to collect attacks against products in development as well. As a product manufacturer, we can put up prototypes. If with the cooperation of product development teams, we can connect prototypes of products to this honeypot to make sure that they to collect threat information or to collect attacks or vulnerabilities on those prototypes to address them before ship. And one thing that we've been doing, the screenshot here is an image of our showroom or our lab in Taiwan. We also have something similar here with smaller electronics here in Japan. And we're also looking to increase global coverage of our observation points. We may not be able to do it physically like this, but we're trying to figure out a way to be able to collect more information on a global scale. That's an ongoing thing right now. So then the next part of after we collect some of the information, some of the things that we've been doing is to collect IoT malware, malware against IoT home electronics. So there's a process there's an internal process here to collect the malware within the honeypot. There's some behavioral analysis that goes on within an IoT sandbox, and these results are automatically spit out within the system and are compiled into various reports that we provide to our business divisions internally here. So we have the behavioral analysis specialized for IoT malware, and this process from collection to analysis and to provide the statistics has all been automated over the last couple of years. And then sort of the next step that we're looking to go through is to make sure that we have proactive protection to our devices and provide feedback to our product developers. So one of the things that we've been consciously doing over the past year is to share what we're actually observing. So not just the malware analysis, but also some of the trends, what they need to look out for and stuff like that. So these are things that our product team is working on to provide more pointed reports as far as what the development team should be working on as far as remediating vulnerabilities prior to shipment. And then the other thing is we want to make sure we have a better analysis platform for this rich data set that we're starting to compile. So some of the things that we're looking at doing is to categorize the attacks using some sort of standard framework. The first one that comes to mind is the MITRE attack platform. Some of you may be familiar with that. We're also looking to analyze targeted vulnerabilities to assess countermeasures specific for Panasonic products. And also, if there's any product-specific characteristics like vulnerabilities and impacts that may affect our products, we want to make sure we're ahead of the game on that. We want to make sure we're using our information proactively to make sure that our products are secure. So this is sort of like a holistic view. This is the last slide, a holistic view of the entire project. You can see the Asura logo in the middle. And we're trying to use this information in various aspects within the product security lifecycle. So like, as I mentioned before, we've already gone through sort of step one, collection. We've sort of gone through, we're in the middle of step two here, which is analysis, which is in the black here. So we're already going through that. We're looking to be able to move this over into sort of the third step here is to into more of the countermeasures. Utilize this information to provide to our product developers so that they can use that information to make sure that they know what to do as far as securing products prior to shipment. But also, if the product is already shipped, make sure that they have this information proactively prior to any external reporter reporting it to us. And then sort of it's not really the final goal, it's not really the final destination, but sort of the last piece to this is to utilize this data to be able to come up with better product security strategies as far as how to use this in how to utilize this from the planning phase and making sure that this cycle goes through. So this is sort of some of the things that we've been working on. That was just sort of a rundown of the project. If you'd like a little bit more detail, please feel free to contact me. We do have a dedicated team. We can discuss this. If anybody's interested, we can discuss this separately. Thank you very much.
Thank you very much, Taki, for a very detailed presentation. I especially enjoy that last slide that you have up with all of the activities that are going on. But your presentation that is showing security involvement at all stages of the product lifecycle, strong internal testing teams being very useful for finding vulnerabilities before the external malicious attackers do, and having an insight into the day in the life of a PCERT and a PCERT team member. Very useful information. I think one thing that is common from these presentations is the usefulness for having a PCERT within an organization, especially one having products. Some of the highlighted differences were shown from previous presentations between a PCERT and a CCERT that, for a larger organization can have both of those teams. And if you're going from an organization that doesn't have a PCERT, I do want to assure everybody that you don't have to jump to such a mature level model that you've seen as some of the presenters here. A PCERT, like all security teams, starts off small and grows from there. There is a maturity life cycle for many different styles of CERT teams, whether they are company-based or product-based. And the examples that we've seen in these 4 presentations are showing some very strong, mature organizational PCERTs that are there. So please make sure that you are starting the journey. And if you're already on that journey, congratulations, and following through and the increases that are there. I think it was Akeo-san that was presenting the information linking back to a PCERT framework that is published by FIRST, the first.org organization and website. A lot of really good information out there. There's a lot of PCERTs that have come together and have documented their processes so that others can learn from that. So please reach out if you need more information. You've got the presenters' names. I'm sure you'll be able to find them, or myself as well. And there's organizations such as FIRST and first.org. I think FIRST is having another returning to face-to-face conferences later this year, just in June in Ireland. So I'll be attending. Hopefully I may see some of the presenters there as well. But there is a collection, and it's an interesting space. A lot of organizations are competitors, but their security teams work together, because if we can make the internet and products secure as a whole, everybody benefits from there. So don't feel that there is company boundaries for a lot of these organizations. Everybody in security is very happy to work together. I'd like to thank our 4 presenters for this session. Excellent information. I'm sure everybody had something that they took away from your presentations today. We only have 1 minute remaining, so I will close it off here rather than doing any questions, and we'll allow the remainder of the TWNIC and ICANN forum to continue on schedule. So thank you again to all of the presenters, and I hope to see you again in the near future. Thank you.
Thank you.
Thank you.
Thank you.
Thank you very much, Mr. Gillespie, for moderating the session for us. And thank you to all the panelists for your very informative presentations. Thank you. Ladies and gentlemen, we will now take a short break. Our next session will start at 3:15. So please be back by 3:15 Taiwan time. Thank you very much. Ladies and gentlemen, welcome back. We will now proceed to the IP Open Policy meeting for the Cooperation Special Interest Group. In this session, we're going to focus on Internet success factors, including scalability, flexibility, adaptability, and resilience. The moderator for the session is Ms. Joy Chan, Deputy CEO at TWNIC. Ms. Joy Chan was the Deputy Director General at Cybertrust Technology Institute of Institute for Information Industry, where she has conducted research in IoT, endpoint security, and device identity. Ms. Chan is a seasoned executive with extensive experience with many large firms in the US, including IBM and Dow Jones. Her expertise lies both in software development and system operation. Without further ado, I will now hand the floor to our moderator, Ms. Joy Chan. Ms. Chan, the floor is yours.
Thank you very much. And good afternoon from Taiwan. I am Joy Chan. I'm very happy to be here. Today, I am going to be sharing about the thing on this session is going to be the Internet success factor, as we said. And I'm just very honored to be here. I think that there's so many things that we cannot live without it today. And Internet is definitely one of it. And we understand how important Internet is. And we are just very happy that we are going to be able to share with you that what are some of the success factors. And I also want to share with you that today I am just very happy and exciting to actually bring an all-star team here. I think I have people from Europe, I have people from Geneva, I have people from the Global South to share the stories, and also from ISOC. So without further ado, I'm going to bring the first set of the panelists. Michael, who works for Analysis Mason, he's going to tell us the result of the Internet studies on the success factors. And also, I'm just so glad that one of my very good friend, Prabal, he's going to be here also to share the initiative of this project. I think this is so good that he has done so many different things in the Internet world, so diversified, and it's just so my honor to have him here to tell you in person what are the initiatives and how are things that's been moving on. And along with Michael, I also have Ahmad, who's going to be also share with that. So the first group, my very, very all-star team, is going to be sharing. So I'm going to pass the microphone to Michael. Michael, why don't you start? How do you want to arrange having this story to be tell the people here in Taiwan as with all the other audience along the globe?
Hello, thank you very much for having us and allowing us to talk about the results of this study. It initiated with Pablo at TWNIC and LACNIC, and I'll first turn over to Pablo to talk about the beginnings of this initiative and what they were trying to accomplish with it, and then we'll talk about the study and kind of look towards the future as well. Pablo?
Oh, it feels really nice to participate at the TWNIC Engagement Forum once again. Thank you, Joy, for your invitation to this wonderful Cooperation SIG. You are the chair of the Cooperation Special Interest Group in TWNIC, and I am so happy that you are replicating the essence of the Cooperation SIG as well in this TWNIC Engagement Forum. Cooperation is such an important element for the Internet to work well, and I think the purpose for this session and for Cooperation SIG is always to uplift the cooperative spirit of the Internet community. I hope that we will be able to do that today. As Michael mentioned, we are going to present the results of a study that we commissioned last year to Analysis Mason about the Internet success factors. I will call this a COVID project because we had some available time to sit down without the distraction of travel and think deeply about what is it that make the internet successful. And it was also a very good cooperation project. It started with IPNIC joining forces with LACNIC. LACNIC, you know, is the regional internet registry for Latin America and the Caribbean. And both organizations pledged some money to commission a study about the technical success factors. So we issued an open call for proposals to conduct this study. And we received, to our surprise, more than a dozen expressions of interest. At the end, we agreed to work with Analysys Mason, a very well-known global consulting telecommunications firm, with a team led by Michael and Amund, both very well-recognized professionals. And it was such a pleasure to work with them in this study. The objective was to build a new narrative, to have an objective assessment of the internet success factors. And I put emphasis on objective because traditionally our ways to describe the internet have been somehow idealistic. So we wanted to flatten the language in which we describe the internet to be less driven by ideals and more about how the internet is actually implemented in different ways across the world. And we also wanted this to be less culturally attached to Western language or ideals. We heard this morning in the forum speakers like Professor Wolfgang Kleinwachter and Jeff Houston, how the internet is increasingly being attacked through different actions. These include regulations that curtail innovation or regulations that have unintended consequences. These attacks to the original principles of the internet include as well the market concentration that we're seeing in the big tech companies. Also, we're seeing new standard proposals for new standards to try to add control, coercion, surveillance, censorship, and adding things that attempt against the open, decentralized, and permissionless nature of the internet. This study also coincided because last year was the 50th anniversary of the internet since it was created. So Michael and Amund will be presenting the findings of this study. And I hope that the study that I will encourage everyone to read help to increase that cooperation among the technical community, about the community in Taiwan, to help preserve those technical features that have made the internet so successful in the last 50 years. So I hope this has been a good contribution that you value. And Michael and Amund will be presenting the contents of this study. Thank you.
Okay, thank you, Pablo, and thank you again, Joy, for asking us to present this paper. It's a wonderful opportunity to spread the results of the study. And again, thank you, Pablo, for choosing Analysys Mason. It really, truly was a pleasure and one of the highlights of the COVID period to have the time and space to be able to step back and think about what has made the internet so successful in its 50th year. So Ahmed and I will present through the paper and look forward to a bit of time at the end to have any discussion or answer questions. We'll also put up in the chat the links to an online version and the full document. And so we identified 4 dimensions to the internet's success. it has successfully scaled to the increased demand from new users and new uses. It has been flexible to all the new network technologies. It's adapted to new applications, and the whole of it has been resilient to shocks and changes, such as the significantly increased demand resulting from the COVID restrictions over the past few years. And this really helps to explain how it went 50 years ago from a research network used mainly in the United States over dial-up access on copper networks to access text-based applications to the global internet that it is today, with over 3 billion users using high-speed mobile and fixed access with all the smart devices and real-time applications such as the one that we're using today to present this. The success of the internet, these 4 dimensions, really had their roots in the guiding ideals of the founders of the internet, some of whom we had the privilege of interviewing as we prepared this this paper. We were able to speak with Vince Cerf, Steve Crocker, and others about the ideals and how they see the dimensions of success. And those guiding ideals, in turn, led to some design principles that are the foundation for the 4 dimensions of success I presented on the previous slide. And the guiding ideals are openness. The internet is open to anyone to help create the standards and anyone to use the core standards, the core protocols in their networks and applications and other services. It's also open to any new network to join and become part of the internet. It's based on simplicity, that it's built on some simple building blocks that can be put together, stacked in different orders to achieve more complex tasks. And it's decentralized in that there's no one that owns, operates, or controls the internet. It is a multi-stakeholder model that is operated by different network operators with different applications and services riding on top of it. And these 3 guiding ideals then explain these design principles of layering, network of networks, and the end-to-end principle that is shown in this slide here. The first of these design principles is layering, that the networks are separated from the applications. They can evolve and operate differently, separately by different operators, different developers, and they're separated by the internet protocol, which acts as a central, stable building block between the layers. The internet protocol, or IP. At the bottom, the network of networks. All networks operate independently of one another, using common protocols with different technologies. This explains the flexibility to new network technologies, where Wi-Fi networks can work in combination with high-speed fiber, increasingly 5G mobile, all operating independently, but using a common protocol and interconnection. And then at the top there, the end-to-end principle, the intelligence in the network sits at the end, at the edge, at the endpoints, so that applications can be developed and installed independently of the network without making changes in the network, so that any of us can design an application, make it available without having to ask for permission from a network to have it installed. So those are the 3 design principles that then feed into and support the 4 dimensions of success. And now I'll turn over to Ahmed, who will talk through those 4 dimensions of success with some evidence, and then I'll finish with a little look towards the future. Ahmed, you're on mute.
Sorry about that. Thank you, Michael. So what I'll try to do is to go through these dimensions of success, and I'll give a few examples of why we believe the internet is successful in exactly these dimensions, and try to also tie that back to the design principles and the guiding ideals that Michael has already spoken about. So the first and perhaps most striking dimension of success for the internet, I would say, is its scalability. Starting from very humble beginnings, today, as Michael already mentioned, we have grown past 3 billion users, perhaps even 4 billion users, according to this figure that you see here. It spans all corners of the globe. And this scalability could not be taken for granted. It comes from somewhere. And as we give several examples in the report of how this scalability is driven both by technical, operational, and business model factors. So on the technical side, we highlight several key protocols in the internet that have proven to be scalable. In particular, the routing system of the internet, the BGP protocol, and also the DNS, the naming system of the internet, has proven over these 50 years. Well, those protocols are not 50 years old, but has proven to be very scalable beyond what perhaps could be expected when they were designed. There are also operational aspects to the scalability of the internet. As Michael mentioned, the network of networks, where the responsibility is distributed across many networks, allowing them to scale and grow independently. And also business models connected to the layering approach, where there's a separation of the networks and the applications that have contributed to scalability. If you turn to the next, Michael, for the flexibility. So in our report, we spend some time on flexibility in the meaning flexibility to run over different network types. So this would be below the IP layer of the internet. Key to flexibility is the layering principle that decouples the underlying networks from the internet protocol and from the applications above it. We can see on this graph how the internet over time has gone from a network that was mainly running over analog copper networks. Then you had the introduction of DSL networks in the early 2000s, several other technologies, towards the situation today where access is really dominated by mobile and fiber networks increasingly. This flexibility is driven, as we mentioned, by the layering principle, but also by some of the technical principles like packet switching and the common packet format that has been very central to gluing together all these different network technologies. If we turn next to adaptability. So by adaptability in our report, we talk about how the internet is used very differently today than it was 20, 30, or 40 years ago. Back then, it was mainly about text. It was about file transfers. It was about email. It was increasingly about web pages. Until today, we sit here speaking over having a distributed conference from all corners of the world. And as the use of the internet has changed, the protocols that are used to support these applications, they have also changed. Now it's interesting that these protocols, they have changed mostly in the lower and the upper layers of the protocol stack, while the internet protocol itself at the core of the internet has been remarkably stable over this period. The graphs here, they show two examples of how protocols have, or the use of protocols are changing in the upper layers of the internet stack. One main development over the last decade is the introduction of end-to-end security and HTTPS. That has we discussed in the paper how this has large implications for internet. And a more emerging change that is going on over the last 5 years or so is the introduction of QUIC as an alternative or a replacement for TCP, which is really one of the very central protocols of the internet. And finally, if we turn to the last of our 4 success dimensions, which is resilience. There are indeed many challenges to the internet. The internet is being attacked every day in the form of DDoS attacks or in the form of viruses, of malware of different types. Many of the core internet protocols, they were designed from the start without really taking security into account. You can think of BGP, you can think of DNS, and now there have been many efforts following that on adding security to these core protocols. And indeed, there are fallouts in the internet, both in terms of networks failing, of traffic being blackholed, in terms of scams and security breaches. But overall, the internet has been remarkably resilient. There have been, I would say, no systemic failures in the internet throughout its history. There have been no lack of predictions of doom and failure, of collapse due to different, be that the scalability of the routing system or be that congestion problems. But the internet has been remarkably stable and remarkably resilient, illustrated in this graph with the extraordinary growth in traffic that came, as Michael mentioned, due to the very changed patterns of how the internet has been used over the last couple of years as a result of the COVID restrictions. So with that, I will give the word back to you, Michael.
Thank you, Alan. Just run quickly through the future outlook and how the paper and the various stages, the guiding ideals, design principles, dimensions of success can be interpreted and used for what is continuously changing on the internet. There are clearly a number of technical challenges to the internet. Security of the architecture is one of them. Quality of service, because across networks, right now, delivery of traffic is using best efforts, not guarantees. There have been delays in adopting new protocols such as IPv6 to address the shortage of IP addresses. Many of these challenges are being addressed through incremental changes in new protocols such as IPv6 and DNSSEC for security, but they're being adopted slowly. And sometimes academics and others are proposing more radical things to change the internet, such as providing quality of service guarantees across networks. But we think it's important to look at what's driven the success and be careful with changes that might break the guiding ideals. For instance, offering quality of service guarantees across networks may require some degree of centralization. It may also be difficult to implement changes because there's such an installed base if anything that's not backward compatible would be extremely difficult to implement and may have a number of unwanted side effects in terms of how they ultimately impact the dimensions of success. Two changes that are clearly taking place or today are the increasing role of governments, which was perhaps inevitable as the internet increasingly took on functions that were formerly offline. Governments are implementing more controls, but we argue that our paper and the way we're looking at it is largely at a technical level, and a lot of what governments are doing is more at the content level, dealing with content that they view as harmful or illegal, or at the data level, trying to localize data. But at the technical level, governments haven't started imposing new protocols or making changes at the technical level that would impact the dimensions of success globally. Likewise, there's worry about the internet, the large internet companies, the hyperscalers, playing an increasing role by deploying network that allows them to carry traffic increasingly across the internet, and that might impact the internet. But so far, we note that ultimately the traffic still has to be delivered using internet protocols over the last mile, and the content providers are not actually implementing private protocols on their own networks, or if they are, such as the case of Google with Quick, they're working to standardize them through the standardization bodies like the IETF. So we're again not seeing any fundamental threats to the dimensions of success through either of these, but it's important to keep in mind, we think, these guiding ideals and design principles when looking at changes in the internet that are being proposed or that are evolving. And with that, I will turn over back to Joy. And thank you again for the opportunity to present this.
Wonderful. Thank you so much, Pablo. Thank you, Michael and Ahmed. I think your work has been done tremendously well. And with that, I'm sitting here, listen to all these different successful factors, make the internet that's happening today, that's so success. I think that I also recall from this morning's Andrew Sullivan, who's the president of ISOC. He mentioned that it's with all the different community that contribute, such as the technical community like IETF, like ISOC, whose preparation for the standards that make it available with the internet, that today that we can actually setting up a lot of things, building on top of the internet infrastructure that make the internet shaped the way that it is today. So many different applications and systems sitting on top of the internet. Sometimes we even forgot how the infrastructure was built. So when we look through the different successful factors, we understand that the different the layers, the design principle that make internet so resilient and so effective today. So with that, I'm very honored to have my next All-Star teams, Adrian. He's actually from ISOC, and he's going to tell us the next stage on the IP side of it. So with that, you ready, Andrea? Let me turn the floor to you, Andrea.
Thank you, Joy. I want to thank you to everyone, to ICANN and TWNIC for getting the Internet Society here together with many of our friends and partners today, virtually in Taipei. I also want to thank Pablo, APNIC, for seeing the complementary nature of our work. I'll tell you why later, and for being a great partner. And I must say, since we are virtually in Taiwan, personally, I love Taiwan. So it's a shame I can't be there today, but I'm really glad I get to take part in this wonderful event remotely, nonetheless. So let's start. I want to start with this statement. The internet, in just a few decades, the internet has really changed all our lives. It has changed the world. But this certainly did not happen by accident. So it's important to ask, why is it so successful? What has allowed it to grow worldwide so rapidly within a couple of decades? So that is why 2 years ago, a team of us at the Internet Society started a project to try to understand what the internet really is. We started off with an exploration of what makes the internet the internet. Essentially, what are the salient features of the internet that have led to its global success? That is important because we believe articulating the features will help us know what to protect and how to ensure a healthy evolution of the internet so that our future generations can continue to benefit from this life-changing technology for us all. On the technical level, we arrived at a few key features that are pillars of the internet. We call them critical properties. So let's quickly run through them. So for instance, let's start from 12 o'clock and clockwise, right? The first one, accessible infrastructure with a common protocol. It is about the fact that the network is open to anyone who wants to participate, whether you're a consumer, whether you're an information provider, or an infrastructure builder. There is no central authority dictating who, how, and where connections are made. The network can grow organically to support the needs of its users. So when this happens on a global scale, we have the internet. It creates a global internet infrastructure that is open. So connecting with one gives you access to the whole internet. You don't need to make agreements with different networks in different places. Let's move on to the next. Open architecture of interoperable and reusable building blocks. It is about the fact that technology building blocks are assembled in a layered fashion. They work together to provide services to applications and end users. Each building block delivers a specific function, like supporting different network types, like ensuring reliable transport, or enabling security, or providing name resolution. Anyone can add innovation at any point, and internet users can adopt, or they can choose to reject those building blocks that bring value without re-engineering the entire network stack. Let's move on to the third one, and the last one that I plan to go into detail. The third one is decentralized management and a distributed routing system. It's about the fact that each of these networks in the internet makes independent decisions on how to route traffic to its neighbors. Decisions are made based on its own needs and local requirements. Again, there is no central direction or a controller dictating how and where connections should be made. So that, again, the network grows organically, driven by their own interests. But the internet involves much more than only technical matters. There is also trust, there is also privacy or security, and that is why we can't just stay on a technical level. The internet society community, and I believe along with all of you here today, share a common set of aspirations for the internet. We want it to be open, globally connected, secure, and trustworthy. And these are under internet goals in the table here. And how do we achieve these goals? We call these enablers. These will help us get to the goals. These will help us get to the internet that we all want. So by viewing proposed changes in policy, technologies, and applications in relation to these goals, we can better understand whether or not we are on track for a thriving internet or straying away from our targets. For instance, the enablers helps simplify the task of analyzing the potential effects of proposed changes, and in consequence, how it may affect the goals. I'll give an example here. A secure internet requires that the internet support both data confidentiality, which is the fourth from the bottom here, and data integrity, which is the third from the bottom. If either is missing, the security of the internet is reduced. Since the enablers, and not the goals, are the tool for analysis of proposals here, they are the focus of our framework. So, have we achieved all these internet goals now? I think we can all agree, certainly not. Are we going too soon? Maybe, or maybe not. We may not even reach a point where we can say that the internet is fully evolved, or that we have reached our goals and we can rest now. We may never reach that point. But what we can do now, since we know what makes the internet useful and valuable to everyone, is to move together in a direction that makes the internet more open, more connected, more secure, more trustworthy for everyone. We have tried to put the framework to use, and the products are what we call internet impact briefs. They are analysis of whether and how a proposal, development, or trend will benefit or harm the internet. So we've done a few, including how, for instance, sanctions will affect the internet's operation, and a few others in different parts of the world. So feel free to check our website to find relevant information. Ultimately, I want to say this. The internet can continue to evolve to address these issues as it has been doing for many years. It has evolved over the years, as Aman has told us just now. But it can only do that if we protect what makes it successful and valuable. That is why we think before authorities and business leaders make decisions that change how the internet works, they should examine the potential impacts. They should think about how it will affect the internet. Many countries do impact assessments for the environment before they build a new bridge or an airport, for instance. Well, there's no reason, we think, why the same shouldn't be the case for the internet, which is really an ecosystem. So I want to end by saying this. We have this amazing tool, the internet, on our hands. Let's protect and defend it and keep the internet that we all want for generations to come, and one that is open, globally connected, secure, and trustworthy. That brings me to the end of my presentation. I want to thank all of you for listening. Back to you, Joy.
Thank you, Adrian. Internet has been around, I think, for a lot of people. Probably when we start using, we never really understand how much the enabler that there is. And I'm so glad to hear you sharing all that. I think that we very often take it granted as it's a commodity. Everywhere we go, we expect that we do have the access to internet. But without all these efforts from ISOC, with IETF, with all the efforts, and it's continue growing and evolving. So there are so many things that's happening on the very bottom side of it, and sometimes we just don't realize. So I'm so happy to hear the different enabler that there is from your sharing. So I'm going to be switching the angle a little bit. Here, I'm sitting here in Taiwan. We hear people from Adrian from Singapore, and of course, Michael, Prabal, and Dhamma from Australia, as well as Geneva. What about what's happening in the Europe side of it? So Chris, this is where I'm going to bring you. I know that you have run a project called DNS for EU. And this is not very familiar for us here sitting in Taiwan, understand what's that. And what does that has to do with the internet, with the DNS, with everything else? So I want to give you some time and let you tell us what's happening there. And the floor is yours, Chris. Thank you.
Okay. Thank you very much, Joy, and thank you for the invitation to be here. It's a real honor and pleasure to be talking with this all-star team, as you called them. And thank you, TWNIC, for putting on this event. I think Pablo is absolutely right. And these sort of cooperation and engagement events are so important to what we do. And yeah, I'm sorry I can't be there in person. I was realizing that the last APNIC meeting I went to was actually in Taiwan, but I'm embarrassed to say how long ago, but I look forward to getting back there sometime. Yeah, I'm coming in with quite a different perspective here, and I do want to sort of first acknowledge and thank the work that APNIC and LACNIC funded and that Analysis Mason did on this report. It's a really important, and I think Pablo, said it, or Michael, it's about really shaping the narrative as we go forward and sort of bringing that understanding to the work that others are now doing in this internet space. And I think I also really want to applaud the impact assessment tool that ISOC has developed, because I think that's another really significant step to practically helping the policymakers and the new stakeholders who are coming into this space and have legitimate interests there. I'm coming from quite a different perspective, because I want to talk about an initiative, actually not that I've been running, but that the European Commission has proposed, called DNS for EU. And it's something I've been talking about a fair bit with our community, the RIPE community, and others recently. And I want to try, I'm going to put up some slides here now, and I'm going to go through them relatively quickly. But I want to try and link this back to those discussions that Michael and Armand sort of really highlighted in that paper about, the scalability, the flexibility, the adaptability of the internet, and what questions this kind of a project actually raises for that, for those principles, and for how we see the internet developing moving forward. So, okay, I'll jump in here. DNS for EU. As you're probably aware, I'm assuming that it's sort of still pretty well known and recognized in the Asia Pacific, European Commission and the European Union have been very active in the field of internet regulation, internet-related regulation. And at the end of 2020, they dropped a whole basket of initiatives and proposals into our laps. There was the NIS2, which is cybersecurity related, the Digital Services Act, the Digital Markets Act, which recently were adopted. They also put out an EU cybersecurity strategy for the digital decade. And one of the things that they proposed in this was to create a European DNS resolver service. So a public resolver service like those provided by Google or Cloudflare or Quad9, but actually specifically European. And so this obviously got a lot of people quite interested, curious to see what that meant. And at the beginning of this year, they actually put out a tender. So they sought people to make proposals to actually do this work to establish an EU resolver service. There is a QR code there. It will take you to the now closed tender document. If you have interest, you can follow that, and I'm sure these slides will be available afterwards. The objectives that the EU or the Commission laid out with this regard were actually quite interesting, because it's a different kind of approach from a government body. So these are the objectives that they looked at particularly here were how to address the consolidation of DNS resolution in the hands of a few companies. So they're worried about the fact that it's big US-based companies that are doing these public resolver services, and that these public resolver services are being used more by people. They see a lack of EU investment in infrastructures that can help detect and filter local cyber threats. So there is a cybersecurity concern element here, and a feeling that more government funding can help that. And then there's the fact that processing of DNS data can actually have implications in terms of privacy and data rights. And I think it's well understood that the EU has a very strong and active interest in privacy and data protection rights. I'm sure everyone has heard of the GDPR and the impact that that has. A few more specific things. It's talking about the need for it to offer a high level of resilience, this new service, to ensure that the DNS resolution data is processed in Europe and that that's not monetized. It's adhering to the latest security and privacy standards, widely discoverable, so public, very public, and then offering optional services such as free parental control. So actually giving users a little bit more granularity in how they can control what they actually want to see coming through the DNS. And then, yeah, this is somewhat reiterating here, the compliance with GDPR and national rules, absolutely key. Lawful filtering of URLs based on illegal content, based on legal requirements in the EU. That's an interesting one, because that means that this service is actually going to filter out certain content, and it's going to be based on EU national jurisdictions, which actually means 26 different national jurisdictions. And then finally, one interesting point is that they wanted it to be a federated structure of governance. So this wasn't that they wanted to have Deutsche Telekom or Telefonica or one of the big incumbents just come in and say, we'll run this for you. They wanted to see a sort of a confederation of different organizations coming together to provide this. Okay, so that's sort of the information that we got. There are also grants included in this. It would be up to 14 million euros. Interestingly, it's just for setting up the service. The cost of operating the service going forward, not really covered. That's an interesting aspect here. And the applicants need to be legal entities in the EU. There was a deadline for submission, 22nd of March. That was extended for a month. It closed in April. What we now know is that there are 3 tenders that have been put in. That's really all we know at the moment. It's gone into the black box of the European Commission, and they're looking at this. So that's the background. We had discussions as the RIPE NCC with our RIPE community because we wanted to hear from that operator community, like IPNIC operator community, what they thought of this project, what they wanted to see out of this project in a quite practical way for RIPE NCC. Did they want RIPE NCC as the regional internet registry to have any role in this? And it's important to note there that as well as the regional internet registry, RIPE NCC is also one of the root server operators. We operate KRoot. So we have some skin in the game here, but we wanted to talk to our community. So is this project useful or necessary? Does the community care who ultimately wins this tender process? Is it going to have any impact on current DNS operations in Europe and beyond? Are the requirements that the Commission has laid out appropriate, realistic, comprehensive? Do they cover all of the issues at stake here? Are there risks inherent in this effort? And then does the RIPE community see any role for the RIPE NCC? There's a URL at the bottom here. You can read more about what we heard. I want to just highlight a few points here though. There were absolutely some concerns that we heard about the possible obligations or requirements on network operators. So specifically, if you're and this relates to the second point here, it's a new kind and degree of government intervention in this space. Currently, you have private operators, big tech operators, many of them, providing a public resolver service, and you can choose to use it or you can not choose to use it, or you, as most people choose to use simply the resolution service provided by their ISP. If you have a government or a government funded or mandated body stepping into this, there are obviously questions. Is there going to be an obligation for operators in the EU to actually use this government provided DNS resolver service? And what would that mean? That kind of leads to the third point there, technical concerns about centralization or consolidation of DNS resolution services. So potentially a single point of failure. And there's an irony there, given that one of the Commission's concerns is consolidation of this in the hands of big tech companies. But there you go. You often find that irony. Hopefully a federated model may mitigate that concern, but this is something that was raised for us in the community. And I think there was strong interest from the community in who is awarded that tender. So we'll certainly be watching that, but there wasn't a strong desire for the RIPE NCC to take an active role. I think speaking for RIPE NCC, we were pretty happy to hear that, partly because it's not really clear the value in running this kind of service, particularly when there is no monetization of the data, which is sensible and certainly what users want and expect. But then where is the sustainability? Where is the business case? So that's an interesting question. Now, I think to try and link this back to our discussion here today, one of the success factors, the dimensions of success that Analysis Mason identified: flexibility, adaptability, resilience. They also identified, climbing amounts of traffic. The internet is changing. It's changing under our feet. The last 2 years have seen a massive shift in how we actually use the internet, the extent to which we rely on it. So I think we absolutely need to be open and willing to think about different approaches, and perhaps the government stepping into a space like this, a new approach from a government, is something that would help, that would be useful. And so I don't fault the Commission for the proposal or for the idea, but at the same time, we need to step back and look at what those design principles are, those guiding ideals are, and think about, does this kind of proposal help us to achieve or to maintain and to live out the promise of those design principles and guiding ideals? Or does it pose a risk? Does it move us into a different kind of space, a different kind of approach that actually might jeopardize the success that we've come to rely on and expect from the internet? So that's kind of the questions that we find ourselves asking in this space. And I think, as I said, the EU and the Commission are leaders in this sense in terms of being very proactive and taking very strong stances, but they're not alone. This is a global phenomenon that we're seeing where governments are taking a more proactive approach. And I think I was disagreeing slightly with Michael there in saying that governments haven't started imposing their will on the technical level. I think this is a bit of an example where that you can see the work and the proposals that governments are bringing are actually starting to have an impact on the technical layers of the internet. And so as the technical community, we need to be alert to that, and we need to be ready to engage on that and talk to governments about any concerns that we have or suggestions for how to improve their proposals. So that's all I had to say. And yeah, thank you again. Thank you everyone for the conversation, and thank you, Joy, for the invitation.
Wonderful. Thank you, Chris. I like your sharing, what's happening in Europe. In RIP, it's going to be the same thing. I think there's a lot of the similarity with AP, with US, with other regions as well. As you said very clearly, in the last few years, internet has been changed a lot, especially with the pandemic, which I don't want to say any more about it because we are all a part of it. But I think that with all the changes that's happening, and I'm so happy that we have people from like Adrian from ISOC and everybody else contribute to this session. Our session is cooperation special interest group, and we like to bring the different views and all the different possibility for the cooperation to make the internet shape to the better for us. So with that, I want to switch over to our two next speakers. One, the first one I'm going to bring is Joanne Phelan. Joanne works for Evidence Action. She's going to share with us about what's happening on the different success applications, success system, the utilization of the internet, how successful it is, and how their company has been using the internet to do their business and their operations. I think it's going to be an eye-opening for a lot of people here in our city, in our regions. So I'm going to turn the floor to Joanne. Thank you.
Thank you very much. 大家好. Thank you, ICANN. Thank you to TWNIC for hosting this event. I have really enjoyed being a part of this session so far, and it has really been a very eye-opening experience for me. As I get started here, let me just share my screen with you. So as I get started here, I want to say that I am just very honored to be here, a part of this group, and learning very much from each of the other panelists before me. I'm here to share just a little bit more about how the internet has played a role in humanitarian work in the global south, and especially for its incredibly impactful work in life-saving ways. So just a few questions for each of you as I get started here. How many of you were able to brush your teeth this morning? And how many of you had coffee or tea with breakfast? And how many of you have given a second thought to where your water came from today? In many parts around the world, around 2 billion people live without access to clean and safe drinking water. And believe it or not, the internet really does help solve this problem. In the global south, for humanitarian work like providing access to safe drinking water, the internet is the difference between life and death. The unparalleled reach of the internet means that communities that have been previously not accessible because of bad roads and poor infrastructure are now reachable for life-saving interventions. The company that I work for, Evidence Action, we provide chlorine treatment, chlorine dispensers for safe drinking water. And how do we use the internet? Let me give you 2 use cases for how the internet facilitates the work that we do. So Evidence Action currently provides safe water to more than 4 million people in East Africa. These are rural areas where there are not many roads that can connect them to other public utilities and public services. We're able to provide these chlorine dispensers. We install them in remote villages, and we have plans to double our impact to reach 9 million people by next year, by 2023. And I believe most of this community, most of the audience here is not in the humanitarian sector. I believe most of you are technical people or working with governments and with businesses. You know that doubling impact or doubling profit or doubling any sort of business or outcome is no easy feat. Scale is all about execution. And if we want to scale our impact, we have to push hard for real-time, tech-enabled data and monitoring. So enter the internet. You might notice on the side of this chlorine dispenser, there's a QR code. Each one of the thousands of dispensers that are scattered throughout the African countryside have a QR code like this. We have volunteers from every village serving as chlorine dispenser promoters. Their job is to encourage their neighbors to use the dispensers to treat their water, and then to report to us when there's ever any disruption of service, when the dispenser is out of chlorine, or if a padlock needs to be replaced, if a lever is broken. And if there's ever an issue that needs to be reported, our chlorine dispenser promoters, they simply take a photo of the QR code or on their smartphone, they tap a button or two, and that instantly sends a message to our data center. The QR code then provides the exact GPS location of each dispenser reported, and that makes it possible for our staff and our data centers to quickly identify which dispenser needs to be serviced and what the issue is. We're then able to quickly and efficiently send one of our staff members out to resolve the issue. As soon as the issue is resolved, our staff are then able to report the resolution back to the data center using their smartphone. And this is important because if a dispenser is ever out of service, the longer it takes to reduce the issue, what we call the downtime, the less likely our communities are then able to use it in the future. And that has an impact directly on mortality rates. Therefore, the internet is critical in providing real-time information to our staff so we can minimize downtime, ensure broad usage of the dispensers, and therefore save lives. Our staff also measure and record chlorine residual in the water of households that we visit. Because we use the internet and internet-enabled tools like ODK and Survey CTO to record and transmit our data, we're able to get data on key performance indicators as soon as our field officers have visited a household. And if we find that chlorine use drops, we can then immediately increase our outreach and engagement with that community. Another way that our dispensers program uses the internet is through mobile money. Our promoters do a lot of work to encourage the use of chlorine. They act as public health officials, community organizers, and chief marketing officers all at once. And in gratitude for their service, we occasionally will provide them with a small financial incentive. We do this through mobile money. Mobile money has absolutely transformed how the Global South accesses banking. In rural East Africa, banks do not operate in the countryside. As you can see, the roads are not paved, access is very limited, and it would not be possible or profitable for banks to operate traditional bank and mortar establishments in these areas. But mobile money works through just the internet and a mobile device. It doesn't even have to be a smartphone. Any kind of flip phone, a standard flip phone connected to Wi-Fi will suffice. And now mobile money can provide access to traditional banking services in a way that was never possible for so many communities before. The internet has created opportunities and access to a previously unbanked population. So now it has allowed for millions of people to save, loan, and transfer money through traditional banks, but in a very untraditional way. And by the way, this is one area that I think the Global South has far outpaced the West. Only in recent years in America has Venmo or Zelle or some of these other mobile money platforms become very popular. But in contrast, M-Pesa has been active in Kenya for easily 10, 15 years. Through the internet, we can now incentivize our chlorine promoters with cash on demand, with instantly accessible money through their mobile money accounts. So in closing, I just want to thank each of you for your different roles in promoting and ensuring a secure, scalable, adaptable, and flexible internet. I'm sure as you were each preparing your presentations for today, you are not thinking of these school children in Kenya who benefit from the work that each of you do in promoting an internet society like the one that we have. And because though the internet provides incredible life-changing conveniences and opportunities for those of us in the West and those of us in Asia, in the Global South, the internet is literally the difference between life and death in the communities that we work in. So thank you to everyone for your hard work, and thank you for the invitation to join this presentation.
Thank you, Joanne. Your story is very impressive. I think that for us sitting the other side of the world, we don't really know what's happening. But your story really was impressive and how they utilize the internet through mobile and others. So I'm very happy to hear that, and I'm sure that the internet can make it a success. It can bring all the wonderful things to the human life. That's really the value of it. So while I'm here in Taiwan, I'm going to be inviting, last but not least, Mei Li to share with us what do you see the success stories or what's happening with the success happening on the internet locally. Why don't you give us some moment to share? Mei Li, you can have the floor. Thank you. Mei Li, I don't think we can hear you. Maybe you want to check the microphone again?
Yes. Can you hear me?
Thank you.
Yes. Before my presentation, I would like to thank to every panelist here, especially Joanne. I would like to answer your question. Yes, I brushed my teeth today. I have my coffee today, but I did not think about where comes from the fresh water. Thank you for your impressive sharing. My name is Mei Li, means beautiful in Chinese. And it is my great honor to be here to share with you the success used on internet in Taiwan. During my past 27 years work at the Institute for Information Industry, my major responsibilities, including 4 parts. And these 4 parts next are divided into the following. First, I and my team promote business to business and business to consumer e-commerce for the Department of Commerce, Ministry of Economic Affairs. So my team had about 20 years of implementing e-commerce for Taiwan's 10 industry also. Second, we organize small to medium enterprises clusters and promote the use of information and communication technology to innovation. The purpose is to reduce the risk of innovation for each micro and small businesses. Third, I had the privilege to bridging digital divide in Taiwan's 24 rural areas, including 15 so-called digital opportunity centers on behalf of my organization as a company social responsibility job. And later, I got the opportunity to share my experience of bridging digital divide to more than 15 economies around South Asia, Middle East, and West Africa. Fourth job is to promote e-government and ICT solutions to developing economies. And after I retired from III 4 years ago, I thought the digital divide is not only the digital divide, but also the social divide, geographical divide, economic divide, and aging divide. So I decided to be a volunteer with the help of the KT Lee Foundation. I teach aiders whose age is beyond 55 to use mobile devices such as cell phones and iPad. I teach them how to use smartphone to learn to sing a song, to listen to the podcast, and manage their exercise and activities, and manage their health situations. And also, I teach them be aware of the risk of using internet. So certainly, I have many successful stories on internet to tell, to share with you. However, next, I think I will concentrate on each part of my past experience, especially on the successful factors of using internet. Next, the first one is the cope with COVID-19. People in Taiwan are relying on internet more ever, especially after the pandemic. And the pandemic has accelerated the shift of Taiwan's people online by as much as 5 years. So, including social distance apps, buying face mask using the healthcare ID card during the beginning of the COVID. Also, information dispatching, fake information or wrong information clarification from the internet. Also, online meeting and online learning have become normal to general public. And we used to order food from Food Panda, Uber Eats, and so on, and including grocery during the pandemic. So I think digital channels have become the most popular alternative to the physical stores and in-person shopping for millions of people during the COVID-19. And after the temporary adoption by consumers, the shopping online, food delivery have become a normal for general public. My observation of the success usage of internet during the COVID-19 in Taiwan are the following. First, we have accumulated a lot of digital assets, including many e-government applications, household applications, healthcare applications, etc., so that our government are able to use the database, then provide many useful applications and services during the pandemic period. Next slide, please. I'm going to share the one-day e-life in Taiwan. In Taiwan, the general public enjoys a convenient life. I think there are around 10,000 convenience stores, abbreviated as CVS, such as 7-Eleven, Family Mart, and High Lives in Taiwan. These 10,000 stores open 24 hours a day, 365 days a year. And they are not only provide grocery shopping, but also play as service front window of many government agencies and private companies. So their services, including many e-commerce services, including the logistic service front for many e-commerce platform companies, including the payment to schools, utility bills, online shopping goods, delivery and pickups. So because of the convenient logistics and inexpensive platform cost, e-commerce in Taiwan has been very popular. In such an island, the 24 hours delivery is guaranteed by most of the e-commerce platform companies. And within the metropolitan cities, such as Taipei, Kaohsiung, 4 to 6 hour delivery is very common. So somebody says that the wife won't ask their husband to buy noodles, to buy tissues and grocery for them after husband leaves their work. Instead, they rather order from PC Home, Momo, because their husband may forget, but those e-commerce platforms won't forget. Besides the convenience of e-commerce, the other service, including many e-government applications, such as e-invoice, so that consumer needs to pay value-added tax through this e-invoice application. And in addition, they can join the 2 months lucky draw every 2 months. So they may get some price as high as around $70,000 US for the first award.
Mei Li, I understand that there's a lot of information that you are sharing with the wonderful success stories here in Taiwan, but I apologize for not being able to keeping the time well. So I'm gonna be ask you to probably we're gonna close the session, but before we close session, I just want to make sure that, ladies and gentlemen, that we all have the opportunity to be able to download this wonderful report from Mason. Analysis Mason, from the work that Prabal, Michael, and Ahmed, the team has been done. So I think the information is going to be available from our website. I also want to thank you, all the speakers. I think that you guys did wonderful jobs. We hear from the technical community. We hear from the internet community. I think that to make the internet success, not only those factors are important, it's really all our works that putting together to make it happen. And we are continue evolving this. I think that tomorrow's internet is going to be better than today. Today, we look at what happened in the last 20, 30 years, and it's still evolving. It's make it better. It's all the different new things that's happening. I think it's going to make our life a whole lot better here and elsewhere. So with that, I don't know if there's any question from the floor or any question elsewhere online. Or any last comments from the speakers? Okay, I am gonna be saying that wonderful. Thank you so much for all the work that you have been doing. And I really, really am excited to have my all-star team coming here to present your work. Thank you very much.
Thank you very much, Ms. Joy Chang, for moderating the session for us. Thank you very much. Ms. Chang, please feel free to take your seats downstage. And once again, we would like to thank all the panelists for sharing your insight with us. We will definitely strive to build a more scalable, more flexible, more adaptable, and more resilient internet in the future. Thank you very much once again for moderating the session for us. Ladies and gentlemen, we will now proceed to the next session, which is the IP Open Policy Meeting for the IPv6 Development Special Interest Group. In this session, we're going to shift our focus to IPv6 development journey. The moderator for this session is Mr. Zhennan Jiang, Section Chief at the Department of Frequency and Resources, National Communications Commission. Mr. Zhang is engaged in regulating telecommunication numbers and supervising the administration of TWNIC. He is also a member of the IP Address and Protocol Committee of TWNIC. Without further ado, I will now hand the floor to the moderator, Mr. Zhang. Mr. Zhang, the floor is yours.
Good afternoon, everyone. It's a great pleasure to see all of you participating in IPv6 Deployment SIG session. I am the moderator of this session. My name is Jiang Zhennan, serving in National Communications Commission in Taiwan. IPv6 Deployment SIG plays an important role in the development of IPv6. The charter of it is to share information, experience, best practice, measurement, and statistics on IPv6 deployment, and to review technical, security, and engineering issues relating to IPv6. In this session, we have two panelists to talk about IPv6 deployment journey. The first one is Carlos Gomez Montenegro. He is the chair of the IETF 6 Law Working Group and also the academic director and the founder of the Master in Internet of Things at Polytechnic University of California. His current research interests focus mainly on the Internet of Things. Dr. Gomez serves as an editorial board member of several journals. The second panelist is Runtime On. She is the Internet Number Resource Manager at VNLink and has been involved in the IPLink community since 2013. She has considerable experience in working as an IP hostmaster, IPv6 policymaker, IPv6 deployment analyst, and the IPv6 trainer. Hope everyone can enjoy this session. Thank you. Let's welcome our first panelist, Ms. Carlos Gomez Montenegro.
Okay, hello everyone. I'm going to share my screen. So I hope that you can see my screen and my presentation now. Okay, so hello again, everyone. Thanks for the introduction. And I'd like to thank also the organization for inviting me to give this presentation, and also to everyone attending. So today I'm going to talk about the current status of IETF standardization for mechanisms and protocols which allow to support IPv6 over several IoT technologies. So this is the table of contents for the presentation. First of all, I'll introduce the topic of Internet of Things, IoT, and which are the challenges that this introduces when trying to support IPv6 here. Then I'll talk about the first effort to support IPv6 over specific IoT technology, which was in this case 6LoWPAN, and later extended by 6Low. After that, I'll also talk about some special set of technologies for IoT, which are called low power wide area network technologies, also called LP1, which are quite special and require some dedicated solutions to support IPv6 on top. So I'll briefly describe also these special constraints in LP1 technologies and which are the mechanisms used to support IPv6 here. And finally, the presentation will be finished with the main remarks in the conclusions section. So the internet is a network where we have been connecting our traditional computers, such as desktop computers, laptops, more recently smartphones as well. However, recently there's also a new trend, which is connecting other kinds of devices to the internet, which are a bit more exotic, quite different from the traditional ones, such as, for example, a light bulb, which could be network capable so that we can turn it on or off remotely, for example, through the internet, or a smart plug, which can maybe have some sensor indicating which is the current consumption, the electricity consumption of the device appliance plugged to it. And perhaps we can also obtain remotely the readings of the sensor, which is the current consumption, and then also we could be able to remotely turn on or off the smart plug. Also, vehicles have lots of sensors and actuators and connectivity, so it is interesting to have some sort of monitoring of the information from the sensors, especially for safety applications, to make sure that the vehicle is in good condition at all times. This could also happen through a network like the internet, a thermostat, which contains a temperature sensor, and then a threshold setting based on which it will turn on or off some heating or ventilation, air conditioning systems. All of this could also happen remotely through a network like the internet. And we may have also other devices like a weight machine or a smart watch or a smart band, which may contain sensors of vital parameters related with health, for example, such as temperature or heart rate, and or the weight machine can provide the weight readings, and there could be health related services that may take the readings, and based on these readings it would be good to maybe detect whether someone's health is in danger. For example, it's possible to quickly detect when someone is starting to suffer a heart attack, and perhaps this can trigger some sort of automated reaction which may even save someone's life. Or perhaps a parking sensor which would be able to detect whether there's a vehicle or not in a potential parking spot. So this information could also be shared through a network like the internet and be readily available for drivers. So this situation is quite different now. So it means that the internet is changing to what is called the Internet of Things, where a majority of the devices in the internet are already or will be in the next few years things, daily life objects, which are enriched with some small devices which contain sensors and actuators and are also network capable. So I've seen already some studies which appear to claim that we are already now in the situation where there are more IoT devices connected to the internet than traditional devices. So talking about IoT devices, let's talk about their characteristics because they are a bit different from the traditional computers or even smartphones. So an IoT device contains transducers, one or more. These would be the elements capable of measuring some physical magnitude, like say temperature, humidity, light intensity, and many more. And they transform these readings into electrical signals that we can handle with our usual electronics. And these devices may also contain actuators, which would be able to perform some actions on the physical world based on the reception of some stimulus, like maybe receiving a command through a wireless message that tells the device to open a door, and then the corresponding actuator would physically perform the action of opening a door. Also, these devices have the same main components as a normal computer, like a microprocessor and also memory. However, these processors' memory would be much more constrained in many IoT devices. For example, if today we want to buy a laptop, probably it will be a 64-bit processor laptop, whereas the processors in many IoT devices would be much more limited, like 32-bit, 16-bit, or 8-bit processors. And the memory available in a laptop today would be around maybe 16 gigabytes of RAM, whereas IoT devices in many cases are much more constrained. They may offer a memory, for example, RAM in the order of just a few tens of kilobytes, okay? And by the way, this is one possible example of an IoT device which corresponds to these characteristics. So here the question is, okay, and why these constraints? Well, that's because these devices need to do very simple tasks, like measuring some sensor readings, measuring the temperature, for example, then transmitting that through a network, maybe do nothing until the next time the same operation is repeated. And this may happen after a while, could be 1 second, 1 minute, 1 hour, 1 day, okay? So we don't need the same computational capacity as in a normal traditional desktop computer or even a smartphone, which is nowadays also very powerful. Also, the communication capabilities of IoT devices are usually limited. The bit rates are quite low, up to the order of 1 megabit per second, and sometimes down to around hundreds of bits per second. And also the data unit sizes are quite small. For example, in the order of 100 bytes in some cases, or in some others, it could be even down to just 10 bytes of payload in a data unit. And the question again is, okay, why these constraints? Well, that's because the applications in IoT typically don't require great bandwidth to be supported. So again, to send just some small sensor readings infrequently, we are fine with low bit rates. Also, if we have small data units, that's good because this relaxes the requirements in terms of memory and also the requirements for processing the data units for these constrained devices. Then there are also energy constraints here, because in many cases, we will deploy IoT devices in locations where there is no access to the electricity grid. And even if in some cases we might be able to plug some device to the electricity grid, in some cases we might prefer not to do it, because then we don't rely on cables, then we have more flexibility, and installation and management is also less expensive. So in many cases, as a result, an IoT device will just rely on a simple energy source, like a simple button cell battery, like the one that would be used here in this device. And However, there is a challenge here because the idea is it is possible to have a device lifetime, a battery lifetime of several years based on a simple battery like this one. However, the idea is that to achieve it, the device needs to be in sleep mode, which is a mode where the device has the communications interface disabled and during which the device cannot communicate. However, it will activate the radio interface sometimes when necessary for the communication. So the idea is we can have a simple device which can do the job, communicate when necessary, and also have a simple device which then when we attach it to a normal daily life object, we don't want to modify the size, the weight, the shape, or even the price of such object when it becomes a smart object. So in order to really exploit fully the potential of IoT devices, we want to have internet connectivity for these devices, because then if we connect this device to the internet, then it can talk to any other of the tens of billions of other connected devices. And also we can communicate with this device. We can obtain sensor readings remotely from anywhere else, just provided that we are also from our device connected to the internet. So then in order to have internet connectivity, there are different mechanisms, but many of us believe that the best way is to have the devices run IP directly. So IP support is needed here for end-to-end consistency, also to allow reusing IP-based tools and protocols, and also because it favors application development. Because if the application interfaces with IP or IP-based protocols, then the application can be developed independently of the underlying lower layer technologies. So the same application can be reused for many lower layer IoT technologies. And also, in particular, we are interested in IPv6 because of its vast address space. So we plan to deploy, there are already billions of IoT devices being deployed. And for that, the large address space of IPv6 is a good fit. And then also IPv6 supports tools for operation without human intervention, so that these devices can automatically obtain parameters like their address, discover who is the router, and so on, without human intervention. However, there's a problem, which is that IPv6 was not really designed for constrained environments like these ones. IPv6 was designed during the 90s for environments which would be resource rich, like say Ethernet, where there would be lots of available bandwidth. The computers would be plugged to the electricity grid, so no energy constraints, computers always ready, and so on. So it was quite a different environment. So it means that if we want to support IPv6 over IoT devices and technologies, then we may need some adaptation. So the first open standard for an IoT technology offering physical layer, MAC layer functionality, which was wireless technology, was in 2003. There was the publication of the first version of IEEE 802.15.4, in short, just 15.4. And this is a technology which in the basic option supports low bit rates, 20, 40, 250 kilobit per second, which was rather designed to support low energy operation. And also the wireless link range would be relatively short, tens of meters. And it supports rather small frame size, 127 bytes at most. Whereas, for example, if you compare with Ethernet, in Ethernet, the typical maximum frame size is 1500 bytes. By the way, 15.4 is really important. In 2024, it is predicted that it will reach the figure of 1 billion units being sold per year. So this is quite relevant, as you can see. So then, shortly after the publication of 15.4, the IETF identified that if we wanted to support IPv6 on top of this technology, there was the need to have some adaptation layer to enable that, for reasons that I will explain on the next slide. So for that, the IETF established a working group, which is called 6LoWPAN. 6LoWPAN is the acronym for IPv6 over low power wireless personal area networks, which is a synonym for IPv6 over 802.15.4. So the work done by 6LoWPAN was finished in 2012. So for around 10 years, we've already had the main protocol suite, which offers the functionality of 6LoWPAN, which is the set of 3 RFCs that you can see on the lower part of the slide around here. If you can see my mouse, my pointer. So the idea is that here it's a little bit covered, but anyway, 6LoWPAN is inserted as a layer, adaptation layer between IPv6 and 15.4. And recently, there have been also some extensions to the functionality that was basic in 6LoWPAN. And before going to the details of 6LoWPAN, just the comment that 6LoWPAN is being used in several important protocol stacks, which are based on IPv6 over 15.4, such as Thread, which is designed for smart home applications, and it's really growing in this space. Zigbee, which is rather generic. It's used in smart home, but also in other spaces. WISAM, which is dedicated to smart utility networks, and this means communication for smart meters. And then ISA 100.11a, which is a protocol stack for industrial environments. So a quick overview of what is the functionality of 6LoWPAN. 6LoWPAN offers at least 2 sublayers which provide header compression and fragmentation. So when a node, like an IoT device, needs to transmit an IPv6 packet over 15.4, the first operation is header compression. So the idea is that by using some techniques, it is possible to reduce the size of the typical IPv6 header, which would be 40 bytes, down to 2 or 3 bytes in the best case. And this is important because every byte that we save means less time during which the device needs to stay with the read interface turned on in transmit or receive mode. So then this is very important to keep high battery lifetime. So then if the resulting packet with a compressed header is larger than what fits in a single 15.4 frame, which recall is rather small, then 6LoWPAN performs fragmentation. So it breaks the packet into several fragments. Each one of the fragments will be carried by a separate frame, which will be transmitted over the radio. And then 6LoWPAN adds a little header to each fragment so that the receiver can receive the different fragments and correctly reassemble the original datagram. By the way, in some cases, fragmentation is not needed if the IPv6 packet, or once compressed, is already small enough. However, it's important to always support fragmentation because IPv6 mandates that the layer below it needs to be able to handle packets of a size of at least 180 bytes. Recall that IPv6 was designed assuming that something powerful like Ethernet would be below. However, in this case, in 15.4, the frame size only supports a size up to 127 bytes. So then in 2012, 6LoWPAN was closed as a working group in the ITF. However, there was shortly after the identification that something similar would be interesting to develop for other technologies different from 15.4. So there was the establishment in August 2013 of a new working group called 6Lo, which, by the way, I am one of the co-chairs at the moment. And one of the main tasks in this working group has been to create new adaptation layers to support IPv6, but in this case on top of different technologies, different IoT technologies, which, however, are somehow similar to 15.4 in terms of their performance characteristics. So here the main idea has been to reuse the existing 6LoWPAN functionality. And in fact, not all the functions, not all the mechanisms offered by 6LoWPAN are really needed in this case. And the different technologies which are supported now, for which there is IPv6 support, are the following. The first one is Bluetooth Low Energy. So this is a very important low power technology, which is being sold in the order of 3 billion units per year already. And we have in 6Lo the specifications to support IPv6 over Bluetooth Low Energy in the star topology and also in a mesh topology network. Then another one is G9959, which is an ITU public specification which describes the lower layers of Z-Wave, which is a technology for home automation, which has like around 100 million deployed devices. And we also have this adaptation layer to support IPv6 on top. The other third technology that's also with IPv6 support is DECT ULE. ULE stands for ultra low energy, and DECT is the technology which is wireless, used in many fixed phones at homes and offices, which allows to communicate a base with a handheld device. So this is useful as a potential way to connect sensors and actuators, relying on the existing base of deployed phones which use this technology. And another one is MSTP-RS 485, which is one of the options for the lower layer technologies in BACnet, which is a set of standards for building automation and control. Then there are two other specifications which are in progress, not yet finished, but should be completed in, say, 1-2 years at most. The first one is IPv6 over PLC, which stands for power line communication, which contains here how to support IPv6 over 3 different PLC technologies, as the ones that you can see on the slide. This seems to have application especially in smart grid scenarios, but also in smart home and perhaps a few others. And another one is IPv6 over NFC. NFC stands for near field communication, and this is a very interesting technology because of its very short range, which is used in payment applications, among others, because of its intrinsic security properties, because an attacker should be like exposed in the middle of a very short size or short range technology link here. So, okay, other than that, we have seen that from 2015, there has been the emergence of a new category of low power wireless technologies for IoT devices, which is LPWAN. So to explain the main reason for the attraction here is that imagine we have a set of sensors that we want to connect to a gateway, for example, over a large area like a smart city. Imagine that the distance between a sensor and a gateway is in the order of a few hundreds of meters. Then if we rely on short range technologies like 15.4, the only way to enable the connectivity between the sensors and the gateway is deploying a mesh network like this with several multi-hop paths and several intermediate nodes acting as routers. And however, there would be another possible solution, which is, okay, the same sensors, which are the white circles here, would be connected to the gateway directly. And this is actually feasible with LPWAN technologies, which give a wireless link range in the order of even kilometers and still offer low power consumption. However, this long link range is at the expense of other degraded features in terms of the communication capabilities of the LPWAN technologies. So two of the main LPWAN technologies are LoRaWAN and Sigfox. And however, they are also very constrained, as you will see now. First of all, they both are based on sub-gigahertz and licensed spectrum. Sub-gigahertz is helpful to increase the link range. And however, there are some regions in the world where this leads to some constraints on the duty cycle, so which is the use of the radio that can be allowed for these devices. In particular, in Europe, in this 868 megahertz band, a device can transmit at most for 1% of the time. So if there is a message transmission that lasts for 1 second, then the device needs to stay silent for the next 99 seconds in average. So this is a constraint on the rate of messages that can be transmitted. Another way to extend the link range is reducing the bit rate. So both LoRaWAN and Sigfox support low bit rates. In LoRaWAN, there's a range of bit rates, and the lowest ones are the ones you can see on the slide below the kilobit per second. In Sigfox, it's always 100 or 600 bit per second. So this allows, again, to contribute to extend the link range. However, it also means that if there's a message transmission at a very low bit rate, it will be very long. It will take a long time. So it will consume some important amount of energy. So to limit this, then what is done in these technologies is supporting very low frame size and frame payload size, to the point that in LoRaWAN, there's a range of options, but in one of them, the maximum size of the frame payload is 11 bytes in one of the options in the United States. And in Sigfox, it's always at most 12 bytes in the uplink or 8 bytes in the downlink of payload size. And in addition, these technologies don't support fragmentation to carry larger payloads. So as you can see, LoRaWAN and Sigfox are even more constrained than the already constrained technologies that have been dealt with in the 6LoWPAN and 6Low efforts. And here you can see how the figure illustrates a bit more these differences between the 6LoWPAN or 6Low supported IoT technologies and LP1 technologies. On the vertical axis, you can see the sustained capacity in terms of bit per second, whereas on the horizontal axis, you can see the frame payload size supported in each case. By the way, for LP1, this corresponds in this figure to the worst case. However, the point is that if we want to support IPv6 on top, then we need to make sure that it works well, even in the worst case of the options supported in LP1. So, as you can see, these LP1 technologies mentioned before, LoRaWAN and Sigfox, are quite constrained. However, there's another LP1 technology which is quite popular, NB-IoT, Narrowband IoT, which is not so constrained. It's more similar to 15.4 or other 6LoWPAN, 6Low supported technologies. Here, this one uses licensed spectrum, so there are no regulatory constraints on the message rates. The bit rate is also low, but not as low as the one in LoRaWAN and Sigfox. You can see the order is around 250 kilobit per second, more or less. Also, in this technology, larger maximum frame payload size is supported. So yeah, this is an LP1 technology which is not as constrained as LoRaWAN or Sigfox. By the way, all these three technologies are very important. At the moment, there are estimates that there are almost 200 million Narrowband IoT, 200 million LoRaWAN devices deployed, around 20 million Sigfox devices deployed, but with plans for 50 million. And probably both Narrowband IoT and LoRaWAN will reach around 1 billion devices in maybe 1 year or at most 2. So if we want to connect devices that use these LoRaWAN, Sigfox, and so on, want to connect them to the internet, then we also want to support IPv6. And in 2016, we did some analysis to see if perhaps using 6LoWPAN would be good enough to allow supporting IPv6 over these, especially the most constrained LP1 technologies, and the answer was no. 6LoWPAN turns out to be too heavy for the extreme constraints of technologies such as LoRaWAN or Sigfox. And there are some details that I will offer on the next slides. But then, as a result, the idea was, okay, we need to create a new working group in the ITF, which was called the LP1 Working Group, established in November 2016, which is still active. And the main goal here was to develop a new adaptation layer, which would be between IPv6 and the LP1 technologies. However, it would not be 6LoWPAN. It had to be something else, much more lightweight and adapted to the special constraints of LP1 technologies. So the main specification for the adaptation layer is already published and publicly available. It's called Static Context Header Compression and Fragmentation. The acronym is SCHC. However, it's very difficult to pronounce, so we often pronounce it as SHIC, which, by the way, is equal to how word in French sounds, which means stylish or cool or something like that. And actually, it's not a surprise that some of the co-authors of this specification are from France. Anyway, the idea is that SHIC provides the functionality, the adaptation layer functionality to support IPv6 over these LP1 technologies. So one of the functions in SHIC is header compression. So with 6LoWPAN or 6Low header compression, there is a way to compress IPv6 and also the UDP header. So 48 bytes of such a header could be compressed down to 7 bytes in the best case with global addresses being used. However, if we consider that the frame payload size can be at most 10 bytes, more or less in some cases, well, you can see how this header size is too large. So then for SIG, there was a new concept developed. So with SIG, it's possible to compress an IPv6 UDP header down to just something like 1 byte. Here, the trick is that the nodes, the compressor, the decompressor share some static context, which is composed of a set of rules, where each rule indicates how to compress or decompress the fields of a header. So as you will see now with an example, each rule has an identifier called the rule ID, and then the rule ID can be expressed in just a few bits, and a header, a packet header that is going to be transmitted is replaced before the transmission by the best matching rule ID. And perhaps some additional compression residue needs to be added. So as an example, if we consider a rule ID of a size of 1 byte, we can define 256 different rules. Each rule could have the content that you can see here on the slide. So basically, it's a description of how each field of the IPv6 header or the UDP header could be compressed or decompressed. For example, if the value of the version field is equal to 6, then the action is we don't send any bit for this field at the sending side. If the flow label, for example, is equal to the value 0, then we don't send, the transmitter doesn't send any bit for this field, and so on. For example, in other cases, the length, IPv6 length field is just ignored by the compressor, so nothing is transmitted here for that, because the receiver can recompute which was the value of the length field from information available at the layer 2, and so on. So basically, if one can know in advance which will be all or most of the values of the different header fields, then it is possible to plan in advance the rules. And instead of sending the whole packet header, then we can send just the rule ID and perhaps some compression residue if anything hasn't been compressed. So that's for header compression. And then for fragmentation, then SIG allows to do the fragmentation with a smaller header. It could be 1 byte, 2 bytes, which is less than the 4 or 5 bytes in 6LoWPAN, also much better for the constraints that we have in the sizes of the frames in LPWAN. And also SIG fragmentation offers 3 modes. One of them is called NOAC, where the receiver doesn't provide any feedback on what happens with the fragments, whether they were delivered or not. But then there are 2 other modes called ACK-always and ACK-on-error, which do provide some feedback from the receiver so that the sender has the opportunity to know which fragments have not been correctly delivered. So because there are message rate constraints, if we send, for example, a packet in, say, 20 fragments and only one of them is lost, it's a pity because the whole packet cannot be reassembled at the receiver. So then with these techniques, it's possible to selectively retransmit only the missing fragment so that finally the receiver can recompose the original datagram. So yeah, as you can see, SIG provides header compression and also fragmentation. However, this specification that I mentioned before is purposefully designed in a generic way, because we knew that the layers below would be like several with perhaps different characteristics. So the idea is that if we want to support IPv6 over an LP1 technology, then some additional document, which is called the SIG profile, needs to be defined or used, basically indicating how SIG would be used over each specific underlying lower layer technology. So this would tell, for example, which are the fragmentation modes to be used for the uplink, for the downlink, which would be the sizes of the different header fields, and so on. So there is already one published SIG profile, which is SIG over LoRaWAN. So at the moment, it's possible to run IPv6 over LoRaWAN with all completed specifications. Then there are SIG over Sigfox and SIG over Narrowband IoT being developed, although they are quite mature. Perhaps in 1 to 2 years, they will be already completed. And also because of the interesting performance improvements that SIG offers, now SIG has also been proposed to be used beyond the world of LP1. So there's specifications which are, however, in more initial stages to support SIG over PPP, which somehow allows to use SIG for IPv6 over Ethernet or Wi-Fi in some cases, and also SIG header compression over 15.4. So now to conclude the presentation, as you may have seen, there is a wide range of IPv6 supported IoT technologies, thanks to the works of the 6LoWPAN, 6LoW, and LP1 IETF working groups. Some of the adaptation layers are still being completed at 6LoW and LP1 working groups. There are already billions of IoT devices deployed, and many more are being deployed. So this means that there is the deployment of IPv6 has some opportunities. So IPv6 based IoT devices, the deployment is also increasing, and there are many interesting opportunities and promising opportunities in many application domains. One of them is smart home, where traditionally there has been a lot of market fragmentation. However, there's a new initiative which is called Matter, where big actors like Google, Amazon, Apple, and what was known as the Zigbee Alliance, now the Connectivity Standards Alliance, along with other partners, are developing and have almost completed the specification of Matter, which provides some application layer functionality, trying to unify the functionality and allow devices from different ecosystems in smart home to talk to each other. So this could fuel significantly the adoption of IoT and IPv6 based IoT in smart home. And there's also use of IPv6 based IoT in smart grid, smart industry, and the opportunities appear to be increasing. So, well, here there are some references. Should you be interested in finding more details about the working groups that I focused on, and also some tutorial academic papers on this. And should you have any question, feel free to let me know here. Well, my email address appears a little bit cut, but anyway, feel free to contact me. That's carlosgo@entel.upc.edu. Okay, so, well, I'll be happy to answer any questions. Not sure if there's time for that today. Otherwise, I will be happy to answer over email. Thank you very much.
Thank you, Mr. Gomez. Let's welcome our second panelist, Ms. Yuan-Tai.
Okay, thank you. And this is the second. I am going to share my slide. Yes. First of all, I would like to introduce myself. I'm Oanh from Vietnam, Unique. And I would like to thank Taiwanese for inviting me. And I have the opportunity to share our activity in Vietnam for deployment IPv6. As you know, IPv6 is very important. We have the presentation from Mr. Karis for a very interesting presentation regarding to IPv6 and IoT. And in Vietnam, we also look forward to deploy IPv6, and we start to deploy IPv6 for a long time ago. Yes, we start, I think, from the 2008, and officially following Vietnam IPv6 Action Plan, we deploy IPv6 focus on the internet network from 2011 to 2019. And now we look forward to promote IPv6 within government agency and other network service for Vietnam. And why we do that? As you know, IPv4 is halted, so we just have just a small IPv4 to deploy to develop their service. So we know that IPv6 very advanced not only for the large spool and also good for the mobile and security. And in the world, we believe that many countries like Taiwan, US, India, Japan deploy IPv6 so well. And other ISP mobile operator in the world deploy IPv6 for a long time ago, and they also had the plan to turn off IPv4 network. And I believe that we know that IETR stopped deploy IPv4 standards and focus on IPv6, and many new services like 4G, 5G, and IoT promote default protocol for IPv6. And in Vietnam, we believe that we must to transition from IPv4 to IPv6 to following national digital transformation and digital governments with the new technology like IoT and 5G. And how we do that? We focus for, I think it's the four main activity following by MIC. MIC is the Ministry of Information and Communication. VNIC is the entity under ministry, and we are following the military policy and other required to promoting, leading and supporting, collaborating to develop IPv6 in Vietnam. We had many training courses per year, and after as you know, we start from the 2008, and now we keep have training course for government agency, and also to focus on new technology like 4G, 5G, and IoT across IPv6 security as well. And otherwise, we have many news and to increase the knowledge of IPv6, not only for IP members, and also we connect to the government agency and other company to develop IPv6 within their network. And also we have some working visits and consulting IPv6 meeting to support ISP, mobile operator, and government agency to deploy IPv6. The key point from our activity, and we promote IPv6 because we believe that IPv4 is out, and we move to move IPv6 as soon as possible. And we start with small and to kick the big. As you know, we start to promote IPv6 from one of the ISP. It starts FPT Telecom, and after FPT Telecom deploy IPv6, and after that we kicked the two big group in Vietnam, like it's VNPT and Viettel group to deploy IPv6. And also we have the task force. VNIC is the committee of the task force, and we do a lot of training and work together with ISP, IP members, and other organizations to deploy IPv6. And where we are, and you can see on the screen, we the number of IPv6 in Vietnam increased from 2016, and after FPT Telecom deployed IPv6, and now we reached 50% IPv6 user in Vietnam, and also for fixed broadband, we had nearly 70% subscribe IPv6, and for mobile, we have more than 40 million IPv6 subscribers, basically on 4G, and some ISP, some mobile operator deploy IPv6 for 5G. It's a Viettel group, and also we have the 27% portal from government agency enable IPv6. And for IoT, for new service, IoT, FPT Telecom deploy IPv6 for IoT, focused on the smart home. And Viettel Group deploy 5G within IPv6 as well. And you can see on the chart, we have the, as you know, last year we launched Internet Speed by VNIC. It's the speed test for internet in Vietnam. So we can calculate the speed test in Vietnam, and also we can calculate the use of IPv6 for country for province in Vietnam. So maybe it's a very good information for us to can promote the ISP and support ISP and mobile operator to deploy IPv6 for whole province in Vietnam, not only in the main cities, but also all of the city and province in Vietnam. And what's next? As you know, we are the VNIC is under the MIC, under government. So there are many policies from government to promote IPv6 in Vietnam. First, the decision of Prime Minister of Government on introducing program for national digital transformation. The IPv6 is one of the main targets of the program. We look forward to have entire Vietnam internet transited to IPv6 by 2025. And last month, the directive of the Prime Minister on development of a government toward digital government and promoting of national digital transformation require all of the ministries, branches, and provinces deploy IPv6 and priority portal and e-public service enable IPv6 and the deadline of the directive this year. And also we have the program, that's the IPv6 for Good program from 2021 and 2025, and we keep promote support government agencies to complete the program in 5 years. And following the three main policy, we will look forward to transitioning Vietnam internet from IPv4 to IPv6 by 2025 and towards IPv6 only. We also support government agency following the IPv6 forward program, but also we promote ISP and mobile to transit to provide IPv6 for all the fixed broadband and mobile subscriber, and also promote the content in Vietnam. Content provider in Vietnam supports IPv6 as well. For IP members, we also promote all of the IP members to have an IPv6 address, and also look forward to support them deploy IPv6 within their network and service. And of course, for 5G and IoT, we keep promote the big ISP to deploy IPv6 within 5G network and IoT as well. And yes, finally, I would like to give you some of the upcoming events from Vietnam. Like the OPM meeting in Taiwan, we have the VNIC Internet Conference next month. And we also have some workshop for government agency in this conference. And also we have the IPv6 forum. And we are lucky to have the monitor from MIC, Mr. Deputy Minister of Information and Communication will be monitor of the forum. And also other event for VNN this year. And otherwise, we look forward to promote human resources on IPv6 and DNS. So this year we will have 7 to 10 workshops on IPv6 and DNS. And finally, at the end of this year, we will have a summary of the first set of IPv6 for GOV program. And that's all my presentation. I hope that the information is useful for you. And if you have any question, I'm looking forward to answer and share with you more. Thank you.
Thank you, Ms. Ryan. Now we have 6 minutes for Q&A. Is there any question about the presentations?
Do we have any questions from the floor on site? Mr. Zhang, we don't have the question from the floor on site at the moment.
I personally have a question for Mr. Gomez. What are the reasons? At what point to time to do things like IoT networking might start to drive the IPv6 adoption?
Sorry, could you maybe repeat the question?
At what point of time do you think light IoT networking might start to drive the IPv6 adoption?
Yeah, so there is already some solutions, some actual commercial devices which are running IPv6 in IoT. For example, there is this protocol stack called Thread, which is a protocol stack where there is IPv6 at the network layer. There is also 6LoWPAN because it runs over 15.4 as the radio interface. And this protocol stack is used in smart home. And for a while, the adoption of this protocol stack was quite limited, but it's increasing. And it will be importantly fueled in the next years because of this effort that I mentioned before, which is called Matter, which is based on allowing the interoperability between devices in the smart home, regardless of whether they belong to the Amazon ecosystem or the Google ecosystem or the Apple ecosystem. And there are 2 key aspects there. One is the protocol stack is based on using IPv6. And the other one is that the application layer in that Matter effort is common. So many devices that may support different lower layer technologies like Wi-Fi or 15.4 at the moment, but in the future that will be more, may be able to interoperate in the smart home. So I think that in the next, say, 5-10 years, there would be like a very significant increase of use of IPv6 in the smart home domain. And there are a few others, like in smart grid solutions, where there's already adoption of some smart meter protocols over UDP, over IPv6, and over LoRaWAN, thanks to the SIG adaptation layer. So my understanding is that at the moment, only a subset of the IoT devices are running IPv6, but I expect that the tendency to support IPv6 should increase more and more in the future.
Thank you for your reply and information.
Welcome.
I would like to close the session. IPv6 deployment plays an important role in the development of the internet. This session brought us informative and forward-looking views about IPv6 deployment. Thank you very much for joining this session and wish you all well. This session has ended.
Thank you very much, Mr. Zhang, for moderating this session for us. And also thank you to our panelists for sharing with us your IPv6 development roadmap. Thank you very much. Ladies and gentlemen, we will now proceed to the IP Open Policy meeting for the Policy Special Interest Group, which is also the last session today. But before we move on, we would like to take this opportunity to invite our participants to help us fill in the online questionnaire. The QR code can be found at the back of your badge for our on-site participant. For our online participants, the QR code can be found in a link in the chat box. For our guests on site, after you complete this online questionnaire, if you can just present this final page showing that you have completed this online survey for us to the staff at the reception desk outside. At the end of the session, you will receive a gift in return. We really appreciate your feedback. All right, we will now move on to our last session today, which is the IP Open Policy meeting for the Policy Special Interest Group. In this session, we're going to focus on policy implementation updates, including APNIC Policy Implementation Update and TWNIC Policy and Service Update. The moderator for the session is once again Mr. Zhennan Jiang, who is the section chief at the Department of Frequency and Resources of NCC. I will now hand the floor back to the moderator, Mr. Jiang. Mr. Jiang, over to you. Mr. Jiang, have you already logged in? All right, so we are still waiting for the moderator to join us back up. Before we wait for the moderator, we would like to invite the participants that in the last session, once again, if you have any questions, please feel free to leave your questions in the chat box on YouTube or in the WebEx. For our on-site participants, you're very free to come to the front to use the microphone stands later on if you have any questions. So the moderator, as I mentioned earlier, is Mr. Zhang, who is the section chief working at National Communications Commission. Mr. Zhang is heavily involved in regulating the telecommunication numbers and supervising the administration of TWNIC. As mentioned earlier, he is also a member of the IP Address and Protocol Committee of TWNIC. So later on, we are keen to hear what the panelists have to share about the latest implementation update regarding policy. All right, I see the panelists and the moderator are all back online, so I will now hand the floor to the moderator, Mr. Zhang. Mr. Zhang, the floor is yours.
Okay. Good afternoon, everyone. It's a great pleasure to see all of you participating in this policy SIG session. I am the moderator of this session. My name is Jiang Zhennan, serving in National Communications Commission in Taiwan. In this session, we have two speakers to talk about internet policy. The first one is George Adagi. He is the Internet Resource Analyst at the APNIC. George is responsible for policy support. The second speaker is Cai Genda. He is an engineer at TWNIC and has been involved in the APNIC community since 2006. He has considerable experience in working as an IP training coordinator and the IPv6 development analyst. Hope everyone can enjoy this section. Thank you. Let's welcome our first speaker, Mr. George Adagi.
Thank you, Mr. Jiang. I will just share my screen. Yep, can you see my slides?
Yes.
Yes.
Great, thank you so much. So hello everyone, good evening. My name is George Udagi and I work at IPNIC as the services team lead for the East Asia sub-region. I also provide support to the policy development process. Firstly, I'd like to thank TWNIC and everyone involved for having me here. This is my first time attending a TWNIC open policy meeting, so I'm very happy to be here. So today I'll be giving a quick implementation update for the policy proposals that had reached consensus during the last IPNIC conference. Yep. To give you some background information, IPNIC runs 2 conferences every year, and we also have the open policy meeting at these conferences. And this is where this is an open forum for the internet community to come together to discuss and develop policies and procedures that relate to the management and use of internet number resources by IPNIC, NIRs, ISPs within the IPNIC Asia Pacific region. So during the IPNIC 53 conference, there were 3 policy proposals under discussion, and luckily all 3 of them reached consensus at the policy SIG and also at the annual general meeting. This was then endorsed by the IPNIC Executive Council on the 12th of April 2022. So I'll dive deeper into those 3 proposals in the next few slides. But during the policy SIG, there were also 3 informational presentations. The first one was Prop 141, and this one was to request to change the maximum delegation size of IPv4 addresses from a /23 to a /23 plus 24. But however, unfortunately, this proposal was submitted after the deadline, so it wasn't considered for a consensus call. But we believe that the author will resubmit this for the next conference at IPNIC 54. So keep an eye out on that one. The second one was by my colleague Sunny Chendi. He presented an implementation report for the policy proposals from IPNIC 52. And lastly, Jeff Houston, our chief scientist, he also presented about the trends of what's been happening with IP addresses in 2021. So moving on to the policy proposals. Firstly, we have Prop 142, Unified Transfer Policies text. So this proposal generally refers to 3 sections in the IPNIC Internet Number Resource Policy document. Currently, the transfer policies are separated for each resource type. The downside to this is that it is quite repetitive, and it is an overhead to the overall size of the policy document. And as recommended in the Secretariat's policy document review report, this proposal suggests combining all the transfer policies into one new section called Part 5 of the policy document. So this will help reduce the duplicated text and make it easier for people to access the relevant information. Also, one important thing to note is that previously, IPNIC was maintaining a public log of market transfers on our public website, but after some discussion at IPNIC 53 and a consultation with the community, it was agreed that we would publish all transfers from now on, which would include mergers and acquisitions, historical resource transfers, and I believe it also includes NIR transfers as well. Another thing to note is that this proposal is not intended to change the existing transfer policies. The proposed changes are only minor rewording or rephrasing of the text for conciseness, to avoid duplication, and to make it easier for people to read and interpret. So the implementation, we believe, will be under 3 months, and there will be some minor changes to IPNIC registry systems and processes. Moving on to the next proposal, we have, actually going back to Prop 142. So you can see in the first 3 columns is what the current policy text looks like. It's separated by the resource types. And under the new under this new policy change, we're going to consolidate all the text into one section, which will be called Part 5. So moving on to the next policy proposal, which is Prop 143, ASN to customer. So the purpose of this policy change is to make the policy document more clear on how APNIC handles customer ASN requests. Under the current policy, if an LIR has requested for a non-portable ASN for their customer, and that customer ceases to receive service from the LIR or returns the ASN for any reason, then that ASN must be returned to APNIC or the relevant NIR. However, as observed by the APNIC services team, some LIRs are stockpiling the customer returned ASNs for future use, and in other cases, assigning to a different customer than they were originally requested for. And some other members are also transferring these non-portable ASNs to other LIRs. And this trend was reported as an operational concern in the policy document review report, and it was recommended to the community to look into these use cases to propose changes to the current policy. And as a result of this policy change suggests including additional terms to address those use cases and to clarify the policy text. This means that if a customer ceases to receive connectivity with the originally requested LIR, the customer can then keep the same ASN when connecting to another LIR and request the LIR to update the WHOIS registration details. They can also alternatively become a direct member of APNIC or the NIR and transfer the ASN into their own account. Technically, once this proposal has been implemented, the ASN requested by the LIR to its customer will then become a portable ASN. So the implementation for this one is 3 months or less than 3 months, and there aren't any major changes to our systems, but more changes to our procedures and evaluation practices. Lastly, the last proposal is Prop 144, Reserve Pool under Experimental Allocations Policy. And this requests APNIC to reserve a /21 of IPv4 addresses from the APNIC free pool for experimental allocations. The author had the intention to have this in line with the spirit of the experimental RFCs being developed at the IETF. So this policy change suggests providing reasonable assurance to the community on the continued availability of IPv4 addresses for experimental allocation requests for the next 5 years. So that means that the reservation will expire 5 years after the date of the implementation. And to give you some stats, in the last 5 years, APNIC has delegated 6 /24s. So the suggested /21 may not be big enough to fulfill the experimental requests for a 5-year period. However, as experimental allocations are only valid for 1 year, we believe and assume that if the delegated address space is returned to APNIC after this period, we believe there may be enough addresses for 5 years. And the implementation of this policy will be completed within 3 months, and this will also require some changes to our APNIC registry systems and processes. So that's the end of my brief implementation update. If there's any questions, I would be happy to answer them.
Thank you, Ms. George. Let's welcome our second panelist, Mr. Cai Genda. Mr. Cai, I can hear you. Okay.
Can you hear me?
Yes.
Okay. So can you see my slide?
Yes.
Okay, thank you very much. Hello everyone, I'm Genda Cai from TWNIC. And today I will present about TWNIC IT services and the policy update. That's my outline. The first one is the statistics of TWNIC's IT members, and then TWNIC's activities and the training programs. and the TWNIC RPKI update, policy update, and we have conclusions and the future works. Firstly, let's see the statistics of TWNIC IP members. Until this year, until now, totally, TWNIC have around 317 IP members. The biggest type is Caucasian IBC. We have 64 members in this type. And here we talk about IPv4 address allocation. Totally, TWNIC has allocated 132,324 IP addresses. And to talk about IPv6 address allocation, TWNIC has allocated 2,551/32 IPv4 addresses. Most of TWNIC IP members have obtained IPv6 addresses. And Taiwan IPv6 user availability. Taiwan IPv6 user availability is 0.46% in the end of 2017, and up to 41.72% in this year, April. And the ranking of Taiwan IPv6 global ranking is 19. So if you are interested in this, you can visit the URL here. Last year, we held the 36th TWNIC IP Open Policy Meeting on October online. We have two keynote speeches. The first one is BGP security threats and the challenges. The speaker is Jeff Houston, the chief scientist from TWNIC. The second is challenges of 5G for smarter applications. The speaker is Alice Chen and from Zhonghua Telecom. Session topics include the cybersecurity SIG, operation SIG, policy SIG, and the IPv6 deployment SIG. If you are interested in this, you can visit the URL of the last OPM meetings. And the TWNIC held 13 IP network communication trainings. So totally, we had 577 attendees, and we will hold trainings this year. And the RPKI service, RPKI is very important for BGP and the security. The number of routing IPv4 valid places is 96.4%, and the number of places C/24 is IPv4 valid space 99.3%. And this slide shows the IPv6 of RPKI deployment. The number of routing IPv6 valid preface is 98.3%. The number of /64 IPv6 valid space is 99.6%. And then we will talk about TWNIC.
Sorry to interrupt, Mr. Tsai, but we are at top of the how will you mind going really to and jumping to the conclusion?
Okay, no problem. Okay. So lastly, we talk about conclusions and the future works. TWNIC has 13 new members in this year, and we will encourage and help Taiwan ISP and service providers to manage ROAs to increase the ROA coverage gradually. We will continually follow the IPv6 training and activities this year. That's my presentation. Thank you.
Thank you, Ms. Tai. I would like to close the session. Thank you very much for joining this session and wish you all well. This session has ended.
Thank you very much.
Oh.
Thank you very much,
Mr.
Zhang, for moderating the session for us. And thank you to the two presenters for sharing with us the policy implementation updates of APNIC and TWNIC. Ladies and gentlemen, this concludes the first day forum. Thank you very much for your participation. The session tomorrow features IP addresses, domain name, security, TWIGF, and TWSIG. Tomorrow's session will start at 9 a.m. Taiwan time. We would like to invite our participants to help us fill out the online questionnaire and provide us with your valuable feedback. For our on-site participants, don't forget to present the final page showing that you have completed this online survey to the staff members at the reception desk outside. We will provide you with a gift as a token of appreciation. Please also remember to bring your badge to our conference tomorrow. Thank you very much for your participation. We look forward to more fruitful discussions in the forum tomorrow. Thank you very much. See you tomorrow.